So are we sitting up here the whole time?
I'm not sure.
That would be weird. Really? Oh, okay.
Answer questions?
Well, I'll answer questions on Lorenzo's. You'll answer on mine.
Take turn.
Aldo.
Aldo, Eric Berger, nice to meet you.
I'm
Lorenzo, nice to meet you.
Nice to meet you, Lorenzo.
That's you. Well, no, this is uniform. The blue suit, white shirt. I get to have a fun tie.
So do we need to give our file to him, or he already has it? The presentation.
There was an upload form,
Oh,
so
gotcha,
I
okay.
pushed it there.
Okay.
Hit it.
So this is a presentation. Not IPv6?
I don't know what happened to the app on the drive.
They'll be here, so Joe has no video slides.
Hopefully someone did something while it was gone.
My back.
Thanks.
Okay. Yeah, I don't have it loaded.
You have the PDF of it?
Yes. Let's see what's the name of your
So,
presentation?
it's the 950. It's just if it's the speaker, it's all that.
Oh, okay, well,
That's you.
so this is the presentation up here, but you're saying that you have, okay, then why don't,
Or does the, or are you only doing screen sharing?
here, why don't you throw it in here, and then we'll bring those up.
No, if you uploaded them, then they should be there. Joe keeps our server up so that, if they went up there, then they should. So Anita was part of the report.
Should be there.
Yeah, although this has got a little white in it.
I don't know her personally, so I don't know if she was around either. So
Well, that's okay.
you have this protected to not allow
Here, let
USB?
me,
What's the problem right now? Can we, this is your paper, right?
Yeah, but you know what? I'll just do.
Information there if you're interested in exactly what we did to do this. And this is a very simplified overview of how the libfuzzer function works in our case. So for instance, we do some checks. If a packet is lower than 8 bytes, it's not RTCP at all. If it's higher than the MTU, it probably never came from the internet at all, so we really don't bother. We have some functions to validate if it's actually RTCP, which simplifies also a couple of things, and then some functions to crawl it to see if it's a sender report, a receiver report, if it's an ACK. Basically, you try and stress test with all of the different RTCP kind of packets and see, and hopefully it never crashes when you do. I was mentioning code coverage, which is actually quite important, that libfuzzer gives this basically out of the box for free. And it's important because it gives you an idea of how many times the fuzzer went through each of the lines in your code. So in this case, for instance, we never went through the point that checks if a packet is too small, because we actually have a check that actually never involves those functions in the first place. But in general, you want to make sure that all your code is actually triggered. Otherwise, you may have some blind spots that are actually not covered and may actually present issues. Core profiles are important. So I was mentioning valid RTCP packets, for instance, in this case, to start from. And there are some packets that libwebRTC provides out of the box, but we are actually contributing some of our own. Other projects like Media Soup by Iñaki Bascastillo is providing others. And in fact, we created together an open GitHub project to actually host more files. So if you have packets that are known to cause problems to parsers, by all means contribute them there so that other people can get them and try to evaluate if it crashes for them as well. The last part of our effort was also integrating all of these in OSS fuzz, because of course fuzzing is only helpful when you do it repeatedly over time and so on and so on and so on, because the fact that it didn't crash in 10 hours doesn't mean it won't crash in 20 hours. So putting it into a framework that does nothing but this, basically just hammering it over and over and over all the time, is actually very helpful, which is what OSS fuzz is. It's a project by Google that basically does fuzzing as a service. So you create a few Docker projects to basically show how you can compile the whole thing. You provide a couple of scripts, and then it's part of the project if they accept your pull request. And we actually did that, so it's part of this. And it's quite helpful because anytime something happens, they notify you via mail. You can check what happened. They also don't just use libfuzzer, but they also use AFL, for instance, as part of their process. So it's quite helpful and a very easy way to integrate all of these. And of course, I went really fast with these just to give you a very quick overview. But if you want to know a bit more about how this all works, a few months ago, we actually wrote, not me, Alessandro Toppi, who is the guy that actually worked a lot on these aspects, wrote an extensive blog post on all of the aspects that I briefly touched here. So if you are interested in seeing how you can do pretty much the same thing for your project, this is definitely a good starting point because it goes into details about all the CLANs, complexities, all that you have to be aware of in terms of creating your function, the sanitizer process. Basically, all those minor details that you may not be aware of that actually do need some processing. And again, as I was saying, we started with RTCP. We did a lot of work with RTP as well, and we did some part with SDP as well. But the SDP fuzzing actually could take some additional work because it's actually text-based rather than binary-based as the other protocols, and so may benefit from some structure awareness that we are not putting in there for the moment. And I mean, we are not doing anything in plugins as well. So we are going to do something like this. We want to expand the corpora files, that project that I was showing you before. And as I was mentioning, libfuzzer is not the only options. There are other options. One of those is actually by Dr. Alex, who is sitting over there. They have a modified version of a browser that actually generates malicious RTP and RTCP packets. So all you have to do is take that browser, point it to the website of your application, and see it die in flames, basically. So it's a very useful and effective way to test, to do fuzzing without actually having to touch the code. And it's part of their Kite framework, so it's definitely something to investigate. And really, that's all. So I don't know if we have time for questions, but I thank you for your attention.
We'll take one question now, while Aldo
Not codecs per se, mostly because in our implementation we rarely. Bernard asked if we also fuzzed anything in the codecs themselves, so processing the codec payload, for instance. And our implementation usually doesn't do any decoding of packets themselves. It usually mostly routes them around, apart from a single plugin. But we do need to be aware of some payload-specific information in RTP packets. So I was mentioning, for instance, checking whether or not a frame is a key frame or not that comes in. And that's very different whether we are talking VP8, VP9, or H.264. In all of these cases, it means for VP8 and VP9, you have to look at the payload descriptor that is standardized somewhere in an RFC, which means going inside the payload specification, having a look at the binary data and do that. For H.264 is finding the right null and figuring out if that's happened. So we did need to do some codec-aware fuzzing as well, but really just limited to the things that we have to do inside our application, nothing related to decoding itself.
Okay, thank you very much, Liz. I wish
Thank
we
you.
had more time, but we have wonderful break times and lunches, so please be sure to ask more questions. Now we have the SIP chain, SIP defense cluster with blockchain from Aldo Febro.
Okay, thank you very much. Hi, my name is Aldo Febro. I'm a PhD student from University of Hertfordshire in the UK. And this paper is about SIP chain, you know, how we can actually leverage blockchain to enhance security. I'll start with introduction, the motivation. Why do we bother doing this, right? And the second is what's the proposed solution, and then what sort of experiments I've done with this, and the result, and some conclusion. Okay, so for the problems, right? As we all know, you know, hacking is on the rise. People are trying to, you know, the script kiddies try to exploit, basically doing, exploit the weak passwords from SIP accounts, right? And then once they broke in, they will use that to make international calls and then rake up some, you know, big bills, right? So, and then for enterprise, usually they're kind of short-handed, you know, because for the CISO out there, you know, Chief Information Security Officers, their rule of thumb is, you know, let's say you have, they only allocate about 10% of the staff to be the security, IT security staff, right? And then out of those 10%, can you guess how many percent know actually the SIP security is even less, right? So what end up happening is, you know, the operation have to take care of the security as well, and then securing all this password for all the users, it can be cumbersome, right? And then it's just not scalable. And then as with, you know, business nowadays going digital, right? Everything real-time communication. So they deploy more and more SIP endpoints, SIP application servers. It's just not sustainable for the department who actually has to maintain this a SIP footprint. So what actually the motive of this is, you know, to explore alternative, right? Because back in the days, you know, you have like a local user accounts, and then every server you have to log in, and then you have to secure, and then you move on to the next. But you know, we have invented like domain. So why don't we make it a domain? So once you join a domain, once you secure it, so it's a similar concept. Why don't we make a domain, you know, so that we can leverage the expertise and then staff. So let's say one university got hacked, and then this information is useful so that other universities can be proactively prepared. That, you know, I saw this incident, and then let's create a firewall rule so that when the same attacker attack your university or your bank or your, you know, organization, you already proactively prepared, right? So this is try to leverage other people's detection for your protection. That's kind of the idea, to leverage their expertise. And it's also to scale and then facilitate the collaboration among, you know, this many organizations, because usually the hackers out there, hey, if I were successful with one bank, I'll try another bank. Because chances are they use the same vendor, they use the same protocol, they use the same methods, right? Let's explore, right? So the idea is, why don't we work together, create a consortium, right? And then share this threat intelligence among ourselves so that it's useful for us, right? And then, but there is no, so far today, there is no way for us to collaborate together. So the motivation is to create a framework so that we all can collaborate and then share threat intelligence, be proactive, and scale the operations, securing the SIP infrastructure. Okay, so the contribution from this paper is a framework to secure SIP system by leveraging blockchains. So this is the kind of the architecture. Each of these PBX actually owned and operated by independent companies, independent organizations, right? And then you have like a front end and you have a back end. So the front end consists of, the firewall to drop the packets, right? And then you have a SIP proxy, can be either, commercial SIP proxy servers out there, you can use open source, doesn't really matter. And then you have an IPS that can actually detect what's going on. And then there's this blockchain client scripts. So this is the one that capture the information and send it to the blockchain. So we treat the blockchain up here as like a database as a service. Why didn't we create just a normal database? Well, and then you have like a trust issues. How can I trust you? Because one of the characteristics of blockchain is that it's publicly verifiable. I can see who actually did it, and then it's secured, and then it's there's no single point of failure. So there are great qualities about this, and then I'm not a database person. I want to be able to utilize this for this purpose, right? So front end and back end. So when your PBX get hacked, right? The SIP proxy will be able to detect there's an attack going on, and usually it will write a log, right, in the log file. And then the IPS need to be able to scan the log and pick those up. Hey, something was trying to exploit this account, right? Maybe too many login attempts failed or something like that. And then the blockchain scripts will then capture the source IP address and send it to blockchain, right? And then the other PBXs retrieve this information. Oh, this attacker just attacked the bank over there, right? And then retrieve the IP address and apply it to their firewall. So, and then of course, you have to maintain this, otherwise you'll come up with a very long list of attackers, right? And then if I were the attacker, I can on purpose do this so many times, so that will become a self-inflicted denial of service, because these rules are so long, and then you inadvertently block your own legitimate users, right? So this list has to be maintained, and then one way to do that is by putting like an expiry timeout. For this, once it's failed, you put an expiry timeout, let's say for 1 hour, so that the hacker find it, it's too much time to hack this one. Let's move on to the next target. That's what we are hoping for, right? Because there's not much gain in trying to, because they also do like a ROI analysis, return of investment. If I keep trying this particular PBX, will I be able to get in? And then what can I get out of it, right? So the idea is to put enough barrier, enough time so that they move on to the next target, okay? So this is the front end layer, the firewall. It is used to drop packets, and the IPS to detect attacks and create firewall rule automatically, right? And then the client scripts to disseminate the IOC, indicator of attackers, and then via blockchain. So this is the attack detection. It's a rule-based log scanning using a regular expression. This is the very SIP proxy specific. So maybe Asterisk has some sort of log format when they detect certain attack, but it's different, to Free Switch, to Gamaliel, to Cisco, to Avaya, to Microsoft. They all have a different, but they usually do write something to the log. And then is also doing a dynamic update so that to avoid self-inflicted denial of service attack. So like for example, for asterisk, right? Every time there is a username or authorization mismatch, it will come up with something like this. So your IPS need to be able to capture this pattern, right? And then automatically write a firewall rule, okay? And then the backend layer is really simple. So it's using a REST API to access blockchain, because otherwise what you'll have to do is to set up your own blockchain node, which is, it's a tall order. I don't want to maintain my own blockchain node and join to the blockchain network. It's just, it's too intense. But of course you have to write a smart contract. A smart contract is basically a code that, a code to access the data, right? So you build a smart contract that basically is a dynamic list of attackers. So that's actually what the smart contract is. And the Ethereum is the blockchain network that supports smart contract as opposed to other blockchain network. Okay, so this is the test bed that I did. For the firewall, I use commonly used IP tables, and then for the SIP proxy, I use asterisk, and for the IPS, I use a fail to ban, which is a very common, comes with many default the Linux distributions out there. And then for the blockchain client scripts, I wrote it in a Node.js because there are a lot of libraries already available out there that, instead of writing from scratch, just use that. And then I set up like 3 nodes in AWS. One is in US and one in UK and one in Singapore. So the idea is, let's say the proxy in US got attacked. Let's see how the proxy in Singapore and in UK can learn about this and set up a firewall to proactively, prevent this attack, right? And then I use the Ethereum Covan, the development network. Okay, so this is kind of the flow, the diagram, right? So this is the attacker. First, it will hit the asterisk, try to probe with wrong username and password. And the fail to ban is you need to be able to detect the log file, the asterisk log file. And then from here, fail to ban, you can write a script to actually add a new rule for the IP tables. So scan the log. Once you found this pattern, create a new firewall rules so that effectively it will block the next packet. So you kind of start dropping packets from here, and then on the back end, it will launch the add IP client script, which will write into the blockchain via Infura. Infura is the REST API that's available for you to use to access blockchain. So that's why Infura is there, because it's very handy. I don't want to maintain my own a blockchain node, right? I just want to make a REST call and the data is there, okay? And then this SIP proxy in UK and in Singapore, I put like a cron job to run every minute to see is there any additional attackers being reported. So I also have a client script, like a get all JavaScript, to go to this blockchain to see any new attackers detected, basically. Retrieve all. And then once I read it, right, the same thing happened. I parse it out, and then I'll create new rules for my firewall. So that's number 4. So that when the same attacker attacked my asterisk, it's already blocked right here. So I learned from what I learned from US, I applied to UK and Singapore. So this can be like a globally synchronized state. I think that's what we want to be able to achieve here. And then the fail to ban also maintain the expiry. So let's say if the account, after 10 minutes, after 15 minutes, or 60 minutes, right, when it's expired, it will delete the rules from the firewall. And also the same thing happen over here. It will delete the rules to the blockchain. Say, hey, we've blocked this for 1 hour. That's enough. Let's, take it off for now. And if it's attacking again, let's put it back on, basically, to make it. So this is like a dynamically maintained. It can grow and expand and shrink, right? So, and the test cases is brute force attack on a SIP1 at US. A couple of wrong username and password, and the new firewall supposed to be created in SIP proxy in UK and Singapore. So the results over here, yeah, this is. Yeah. It's a firewall. Yeah, it's the IP tables rule. Yeah, because when you detect when the asterisk got attacked, right, in the log file, it captures the source IP address where the attack is coming from. Correct. Yeah, who is the attacker? So that's the one that being shared, and then you put this into the firewall so that the next packet comes in, you know that this is an attacker. You'll start dropping the packet, and then you share this attacker IP address with the rest of your community. Did that answer your question? Yeah. Okay. Okay, so over here, in asterisk, found like 3 attempts, right? So it start banning this particular IP address, the 52. This is an AWS public IP address space, right? And then over here, in a SIP A, and then this IP tables, normal IP tables rule. And then over here, you can see that is the new firewall rule already installed over here, this source IP address, and then it start rejecting because this has been detected as an attacker's IP address. Okay, and then over here, the blockchain scripts also disseminate this IOC indicator of compromise via blockchain, and it will give you the transaction hash. Yes, this transaction has been committed, and then this is the hash for you, and then this is the input data. You can see that this the same attacker's IP address is captured over here. Okay? And then over at the server in UK and in Singapore, it retrieves this attacker's IP address and then create its own firewall rule. So over here, as you can see, this new firewall rule is created over at in UK, right? And then the time, as I put it, like every minute, a cron job to retrieve. So it's like a 1 minute apart. So over here is 21:28, and over here is 21:29. So you can do it in a pretty timely fashion, right? And then the same attacker attacks this SIP proxy, and then you can see it start dropping packet. Right, over here. So the 43 packets drop coming from this particular attacker's IP address. Yeah. So the conclusion, actually we can actually scale the protection. And one way to do it is to create this framework, a domain where we can share information about the attackers and help your organization to be proactively prepared so that it helps to scale the SIP security staff in your organization. And then together we collaborate, we work together as community to make our environment safer. But is for blockchain itself, right? The ecosystem is under active development, is growing every day, and especially when you write the scripts, what happens is you have to be really careful about what libraries you use, what function calls you use, because these libraries change all the time. You have to make sure it's all line up and it doesn't break, right? Because it's still under active development. But for what it's worth, we can take advantage of the blockchain, right, while mitigating or and recognizing the limitation of it, right? But I think, as we move forward, it's a community effort that we want to foster and collaborate together. That's all I have. Thank you very much. Any?
We have time for a couple of questions.
Yeah.
We have about 4.5 minutes left, so go.
Yeah.
You need to repeat her question.
Okay. Yeah. So the question was, what sort of attacks, right? That I did test over here. So I did a brute force attack. So I simply supply with wrong username and password for 3 attempts, right? And then it detected that yes, it's actually captured. Somebody was trying to hack into this SIP proxy, and but brute force attack is not the only attack that can be detected by Asterisk, because Asterisk can also detect other kinds of attack. It's actually, what it does is it simply create a log entry depending on, hey, this peer not supposed to register, why is it here? So there's a log for that, right? Or maybe it's using a different encryption algorithm that's not supported, or maybe, hey, this SHA is not supported, why is it here? So different kinds of attack that Asterisk can actually detect. So this is not only, it's a SIP proxy specific, because what kind of log entry created is different from one SIP proxy to the next. But you can adjust your intrusion prevention system, IPS, to recognize a different pattern, right? And then it will launch this add IP or delete IP script.
Other questions?
So everybody can hear.
So are those detection methods already predefined, or we have to manually enter them as a rule that, hey, if so-and-so register is sending the so-and-so IP or this subnet, then that should be blocked, or that's a restricted IP. How do you make the rule set?
Okay.
Do you have to, is that predefined or?
Okay. So so Asterisk come with like a predefined attack rules, right? So it's actually it's a 2 sources. One is Asterisk itself, I recognize what kind of attack, and the second is I use a fail to ban. So the fail to ban already has a rule set that, hey, I recognize this kind of entry coming from Asterisk, and then what I will do with it. I will ban or unban, right? So this is within the fail to ban. So I take advantage of these two. If you look at the failtoban.org, they have a list of rules that's already predefined, but you can always add your own rule if there are something specifics in your environment that, hey, this particular attacker trying to exploit this weaknesses on your system, and then you can see that every time he did that, Asterisk or your PBX wrote this line, and then you can create a rule for that on this fail to ban. But this is just the general concept, right? You don't have to use fail to ban, but you can also use other IPS as well to achieve the same effect.
This is interesting because I'm doing blockchain every day, and the fact that you're putting this SIP protocol into the smart Ethereum. So are you doing a proof of work in that section of the smart contract, or what are your rules for that, for the blockchain portion of it?
Yeah, this is the idea is to leverage blockchain as a way to disseminate this attacker's IP address, right? So and this is I use it as a database as a service.
Oh, okay.
And then because it's publicly verifiable, right? So in my community can see who actually commit that transaction and whether this is a trusted organization or not, right? And I want to keep it close. I want to keep it within the consortium. Maybe it's a healthcare consortium or a financial consortium or a university consortium, because we all share the same needs, right? And same protection requirements. So that's why this as a central repository, and then you have, you know, all the good qualities about blockchain, right? Distributed, permanent ledger. I want to leverage all that, right?
Okay. Thank you very much.
Thank you.
That's interesting.
It's doubly redundant.
That's true. Do you mind having?
Yeah, I don't mind.
He's very good.
That's right.
And he's gonna talk to us about dynamic 5G network slicing for first responders. So,
I forgot how to get this to you. Oh, there we go. That's right. And now for something a little different, but just a little different, because this is the intersection of wireless and emergency responding and sort of the traditional RTC kind of stuff. This is a work in progress. So when you ask me, well, how well does it? We're getting there. Some of you know I've been a little bit busy lately, not doing research. So I do have to do the usual disclaimer. This is not the opinion nor the policy of the FCC. I may happen to be at the FCC, and Ken Carlberg may happen to be at the FCC, but notice the affiliations.
Is actually the CTO of the FCC.
Yeah.
So Eric also is a graduate of IIT. So.
That's right. Yeah, yeah. So to get your graduate stuff here, it's great. So I'm going to talk about you know, a little bit of what the problem is, how we're addressing it, why it's a problem, and what we're planning on doing. So, you know, there's busy hour. You know, we've done telecommunications engineering. And then there's, who knows what this is? I'll give you a hint. You're seeing a lot of pink hats. Yeah, this was the Women's March. I think I was probably, because this was the, well, that was still Constitution Avenue, but it was a lot closer. I mean, I was probably about way out here. So a lot of people, and yes, the communications industry said, hey, it's the inauguration. We're going to put a whole bunch of mobile cell towers to be able to deal with crowds, except this wasn't on the mall. This was on Independence Avenue, a few blocks away from the mall. So you can imagine cell systems were totally swamped. This one? Anyone know what that one is? That was the Boston Marathon bombing. So at the finish line, all of a sudden, everyone's calling 911. This one is a little bit of local to DC imagery, so that's obviously DC. But this was, I think, 2011. Does anyone was in DC in 2011 and remember what happened? So we had an earthquake. That's where the cathedral, the top of the cathedral fell and all that. And again, everybody out on the street all at once. It's a flash crowd. And especially as we're talking about first responders, we're talking about calls to 911. These are the times you expect a lot of people to want to make a call all at the same time. And the problem is with the current communication protocols, the user elements, basically the phones, can't even log into the network to say, hey, I want to make a 911 call. I hate to say this, but there's still some PSTN think. Here we are 12 years into IPT-COM, and we still have telephone networks that think, well, it's a really dumb edge and a really smart core. So there's, and by the way, yes, there's the other ARP. As I was getting into 4G and 5G wireless, ARP, I know what ARP is. Oh, that's not my ARP. So this is allocation and retention priority. So the good news is if you get on the network and it's a priority call or you are a priority caller, so there's a service called wireless priority service. It's when the general is out at a conference, the missiles start flying or the troops start moving, they have to be able to make and receive calls. So they get priority. And so we do have this concept is once they get onto the network, once their phone authenticates with the network, then they have priority, but they still have to get onto the network. And of course, what this ignores is as you're getting onto the network, you're just any old user. Even if you want to make a 911 call, even if you are a priority user. I mean, once you're in, then it's cool. You can preempt people and all that, but not cool before you get in. So I mentioned wireless priority service. The idea, since we are moving into, finally, I said there's still some PSTN think, but hey, we've got this IP packet switch network, and again, the reality of it working almost all the time is a lot better than it's guaranteed to work none of the time. I mean, supposedly Bell system guarantees. And so we established these 16, we call them access classes. And basically, normal users, when you pick up your phone and you make a call, basically the phone will randomly pick a value between 0 and 9. And so that deals with like people saying, oh, look, I'm at the Women's March, right? As opposed to, help, the person next to me just had a heart attack. One of those calls has to go through, the other call kind of should. And by the way, if everyone's taking pictures, you kind of randomly pick who gets to go, which is, it's a fairness kind of algorithm. But then when you get to those access classes 10 to 15, those are the calls that need to go through. Unfortunately, your 911 call is 10 because, yeah, they still expect the general to get through before the 911 call. And oh, by the way, 10 will try and try and try again, whereas like 14, it's supposed to always get in. You may have heard, and we've talked about this over the years, FirstNet, which in the United States, public safety network, pretty much all the devices come in trying to be in 14, but they'll fall back, on the FirstNet, but then they'll fall back to the public network, but again, have that higher access class. A great way of doing spectrum sharing, by the way, instead of allocating all that bandwidth to public safety all the time when it's not being used, regular people can use it. It's an efficient allocation of resources, but then when bad things happen, that public safety need can still use that bandwidth. So, we have to do something new when we're researchers. So, like we just said, oh yeah, we know how to do logging and all that. Let's do the blockchain thing because it's got these properties. So yeah, we kind of know how to do priority. Let's talk about 5G. So 5G has this concept of network slicing. This idea that I can share and use infrastructure. So like one base example of that was like the FirstNet example I just gave, that we're sharing the infrastructure, but that's at a very granular level. I'm either on the FirstNet network or I'm on T-Mobile or Sprint or AT&T that happens to get some priority. And there, in 5G, we can now split things like have people share actual spectrum, they can share base stations, they can share at the network layer. So we can actually have, like in a rural area, AT&T and Verizon can actually share a tower. The way it's done today is they share a tower and they both put antennas on it. Well, now and they have to have different spectrum. Now we can basically create a virtual, it's just like we've been talking about this for 20 years. We're actually doing it now, finally. And then all the way up to the service layer. And again, the vision there was, well, obviously you would use, an AT&T customer would use AT&T's CSCFs, a T-Mobile customer would T-Mobile CSCFs. And oh, by the way, we can even make it easy for virtual network operators to then all the way down share all of this infrastructure. And engineers being engineers went, well, what would people want to do this slicing for? Create this virtual network. And I know what we're going to create it for. We're going to create it for different types of media. Because we know real-time interactive video has high bandwidth, modest latency, and okay jitter requirements. Real-time voice, low bandwidth, but very tight latency and jitter requirements. So we'll create these slices so that, and then we'll do access control, the marriage of the best or worst of the PSTN to the IP network. That, we'll guarantee the bandwidth for like that voice call, so it's got, really good quality. And so basically what's standardized in 3GPP are what you'll see here, MTC, which is machine type communication, which is yet another way of saying Internet of Things. Critical MTC, so that's ultra low latency, and that's where you start thinking of autonomous vehicles, things like that, where again, it's Internet of Things, but the message has got to get through, and it's got to get through in really low latency. Massive MTC, this is all of your temperature sensors in homes and all that. Not so important it gets through, but there are gazillions of them. And in a sense, that slice is almost to keep them off of the other slices. And then MBB, mobile broadband, because, man, we're going to get our YouTube really fast. Again, the key issue here is that these service slices are built around the service. So, for example, you may have heard of the term V to X. So vehicle to the infrastructure. That's great, but there's no distinction between I'm ordering a pizza and going to pick it up and a first responder trying to get a notice to you, hey, this is huge from the public safety community. There's an accident on the side of the road. The first responder is out there. Please tell the cars around so they don't hit the first responders. David, didn't it just happen like last week? A first responder got hit in Maryland, I think. Yeah, and that's like less than ideal when the rescuer needs rescuing. So the other bit about this is these things are kind of set up beforehand. They're not dynamic. I subscribe to the massive machine-to-machine communications. I subscribe to the video service. So that sounds like I'm almost ready to tell you the problem. Last bit, so this is just, again, more of that. I won't go into this picture too much, but basically it's done up front, which, if you remember those pictures of the marathon, the Women's March, the earthquake, you don't say, yeah, there's going to be an earthquake tomorrow. Let's set up some slices. And the IETF, everyone wants a piece of network slicing because it's cool. Working on protocols to allow for how you do this provisioning. So what we feel is that we can put all of these pieces together and come up with dynamic slicing for first responders. So what are we trying to do? We're trying to optimize that slice creation and then allow sensing. So, yes, you could do it. It's like, oh, hey, this march got to be a lot bigger than we did, let's push the button. But in a sense, that's already too late. You know, an earthquake happened, I'll push the button, except my command center has been evacuated. So you want to be able to dynamically detect these situations. So what our approach is to have a threshold of where we notice that these access class 14 handsets have just appeared. So yeah, you know, if you're the general or you're a first responder and you walk through a cell site, that's like normal. But if all of a sudden there are 20 in a sector all at once, there's you know, we can infer that there's something going on. And to use that to create or expand a first responder slice. And that it's dynamic. You know, as they leave, we can again free it up. Because again, the optimal use of the spectrum, because after the event happens, yeah, people will probably be taking pictures. You know, nothing to see here. Oh no, I'm going to put that on Twitter, right? We don't want to block people from doing that, but we don't want that to block the first responder. As we're talking about first responders, though, there are a couple of security issues. One thing is we can't totally rely on, you know, the packet says I'm a first responder, trust me. So this is a thing, this is again into our work in progress. You know, since right now pretty much anyone can kind of say, if you can get at the firmware of your phone, you can say you're access class 14. Looking at ways of how to defeat that, because that would be an obvious, like, terrorist kind of thing. Saturate the network with priority people, set off a bomb, and then the real priority people can't get on because the network thinks they're already there. We do show how easy it is to basically find out, to see what a first responder looks like, and then be a first responder. That's about $2,500 of eBay sitting on that seat there of a software-defined radio. So it doesn't take much. And of course, those prices are coming down. So that was some of our prior work. So you'll be shocked to hear we're not planning on building this and setting off a bomb to see what happens. Our next steps, so this is the work in progress part, is to simulate both the protocols for doing the dynamic slicing, but also to work on the algorithms, because we have some moving average hysteresis hypotheses that will work for this, but we want to actually try it out. The principal mode here we were going first on was VoIP. But again, one of the motivations is a first responder takes a picture or takes a video. We don't want that to be classified as YouTube. We want that to be first responder level. And then, of course, feed stuff back to the community. So with that, I'm perfectly done. And no time for, or 5 minutes. Oh, rats, I was trying to run the clock out.
No, you did fine.
Yeah. And since Carol tried to embarrass me, I will try to embarrass David Firth, who truly knows about public safety issues. You're deputy chief in the Public Safety Bureau, primarily on stuff like first responder, and we can credit you for FirstNet. That's right. That's right. Yeah, that's right. So save your questions for him for this afternoon. That's right. That's right.
Hi, Eric. Bob Blair Smith, T-Mobile for Government. Thanks for this. As you can see by the
Thank you very much.
I've actually, Eric Hagerson sends his wishes. He's unable to come today, so my team is here in his place. Question, you started with WPS and, of course, the GETS process. Mm-hmm. So it seems to me most of what you've described effectively supplants the need for WPS and GETS, or is there a next generation version of that? And then also, secondarily, there are still, although we expect in the next 2 years it'll come to a fraction, there's still a small amount of circuit switch traffic based on the available spectrum that various carriers, including even FirstNet, right, would still be handling. How does that play in terms of first responder services?
So this is where I really get to luxuriate in, I'm talking in my Georgetown capacity, so we'd love to come up with algorithms and an architecture, and it would be even really cool if people actually used it. But I can't talk to, the future of WPS or GETS. Yeah, I mean, as someone who's getting more and more involved with Spectrum, I would love to make it so that we can do it dynamically, so the people who really need it can get it, but we don't waste Spectrum by having it reserved almost all the time. But that's a policy cut, which I'm...
Can I rephrase it?
Yeah, sure.
It seems like slicing and other capabilities that you described would seem to me, technically, if we just stick to the technology and let someone else handle the policy. Sorry. The technical solution seems like it would not invalidate, but make obsolete the WPS and GETS. Is that essentially what we're
It would,
mapping?
How about well, like you said, it could be a nice next generation technology to consider. Yeah.
Hi, Dean Bubley. That was really interesting. I'm curious as to how you join up the transport bit with the RAN, particularly because the RAN is going to have all sorts of complex stuff like beamforming, and so you've got sort of spatial sharing as well as capacity sharing. How's that going to coordinate?
So that's what makes it interesting, and that's why I pulled back to the network slicing model. As Dean was saying, it sounds like we're talking a lot about this. But yes, obviously it talks about this, and as well as this, because a service layer may well be, AT&T for FirstNet, but it may be someone else that wears purple for some other services. That's right. But again, it's based on that first responder service. It's not based on I'm a T-Mobile subscriber, I'm an AT&T subscriber, whatever. So yes, definitely. And that's part of the IETF work, is being able to allocate, because now we're into MPLS land, and to say, no, really, I want a virtual circuit between that particular set of base stations going into the core.
I was thinking more from the base station to the user, where you could do beamforming with how you reserve radio capacity in 3 dimensions.
Yeah. So the question is, how do we reserve radio capacity? Because we are doing, beamforming and cool stuff like that. Well, the problem there is we still can't fight physics. And the physics problem is those handsets with 0 through 9 are still going to be trying to say, hey, I want to take I want to tweet. If Marty has his way, Marty Cooper. Carol, Marty Cooper. Our Marty Cooper, the Marty Cooper. If he has his way, because we are talking about this in the TAC, is being able to actually focus on a handset. Not like a room, which is where we're kind of at, focus on a handset. That'll be even after this replace, right? Yeah, it's still science fiction-y, but the math works. Yeah. So I guess one last question? Okay.
Well, okay. Let me break it down to 2 questions. First, you've got.
I want 3 more wishes.
You've got the 5G model up here, so you're actually sure this is. I know you're not speaking. You're saying sure this is going to be. U.S. will have 5G ubiquitous in the United States. I guess that's your assumption, right? I'm sure they'll have it in D.C. But when 9/11 happened. Because it was in Washington, D.C., did everything just go to level 14 and just block out all of the local responders? Because I'm sure that was probably the case. And then how many, particularly in D.C., how many access calls can you all get if it's 9/11, like that march or something happened? That way you would just shut things down.
You know, that question is so easy. I'd let someone in the audience attempt to answer that, Dave.
You want me to answer that? Yeah, whatever.
I don't want to answer it.
Well, if he's gonna answer it, he's got.
I know, and I know you're not going to answer it.
Well, all I can say is we're talking about technology from almost 20 years ago. It was a different world. In fact, I think to answer your basic question, in Washington, D.C., during 9/11, basic first responder communications, which were on 800 megahertz land mobile radios, actually worked pretty well. In contrast to New York, actually, because in D.C. they had actually worked on the interoperability problem, whereas in New York they had not. I think that cell phone lines and other public communications networks were pretty jammed up. That was a fairly typical experience. But we are dealing with a different technological world now, so I guess in the nightmare scenario where if we had another 9/11, the question is, would it happen differently? I'm going to rely on Eric to tell us that it would.
Yeah. Well, and the other thing about 9/11 in New York is there was, a lot of the infrastructure was taken out. But unfortunately, Anita's here.
Thank you. Eric, thank you very much. I probably never embarrassed you. I don't even know why I did to embarrass you. But Anita Nikolic has got the last 15 minutes here.
If I could find my presentation.
Should be there. If you need any help, Joe will help you. And Anita is going to talk about a new internet. The name officially is Designing a New Internet. Did you find your slide?
I did. Do I need to adjust this here? Okay, well, I'll just, someone who's better at AV can adjust it. That's an awesome lead-in. Oh. I'm audio-visual challenged. That was an awesome lead-in. Thank you, Eric. This is great timing. So my name's Anita Nikolic. I'm in computer science here. Thanks for they squeezed me in with a 15-minute talk, so I'm going to talk really fast, faster than I normally do. So I'm going to talk about something called Fabric. It's a brand new NSF grant that we got 2 weeks ago. I'm the co-PI on it and the co-director. It's a $20 million grant. So this is a team. It's led out of University of North Carolina, a research institute called RENCI. IIT is a co-director. We got a bunch of people, including the Department of Energy, and I'm going to tell you why that's really important. So we're leveraging Department of Energy fiber, which goes across the U.S., Kentucky, Clemson, and a bunch of other places. So what's Fabric? What is it? Why do we need it? So if anybody here is an academic researcher, you've probably written a paper that said something like, the internet is showing its age. And you probably have written that like many, many times. If you're like me, I'm a network operator. You've shaken your fist about how BGP stinks and it needs to be replaced. And probably not during my lifetime will it be replaced. But really the mantra is the internet's showing its age. And applications were designed just differently 40 years ago. But what's changed now? Why do we need a place to test at scale? Compute is cheap, storage is cheap. We can put it directly in the network, and we can do better programmability. If anybody here plays with OpenFlow or SDN or P4, these things are getting easier to put both at the core and the edge to enable programmability. A lot of advances in machine learning and AI, and of course with 5G and IoT and different kind of cloud technologies, you wanted an integrated platform, a computer science test bed to try to test all these. The problem is when you're trying to do 5G slicing, you're trying to test a new protocol at scale, maybe something like NDN that's going to replace TCP/IP potentially. There's not a great place to do it at scale that's not IP-based. So you're always hamstrung by the equipment that's there. This is an opportunity for the community, and by that we mean both academic, the industry, government, the community, the network community, the security community, to push the boundaries, to get more control over the data plane, more control over the network, use it as perhaps a big data instrument, and design new protocols. The key being, and I'm a security person, having security built into it. So we have 4 main use cases. The 5th bullet that you see is really to help the next generation. So we're going to have high schoolers and college students help us build this platform. Much of the grant is intended to be used the first 2 years to literally build this out. But our 4 use cases are for a new internet, design new internet protocols, security, integrating HPC wireless and IoT to have this diverse environment. One of our drivers I'll talk about is actually first responders, so they can do more processing at the edge, not have to backhaul, during a hurricane, all that information back to a data center. And to be able to integrate machine learning and AI, there's like this dream of making self-driving networks. And if you run a network, the last thing it does is self-drive. But it would be nice to get more intelligent information across the WAN from the network itself. So this is the core. A lot of these points you see, we are leveraging. The yellow is our supercore. It's a terabit supercore. So what we're doing is leveraging Department of Energy. They are rebuilding their network, which is a science network, to bring back physics traffic and genomics traffic. We're using their optical links. We're getting dark fiber. We're leveraging that. We're leveraging some of their data centers, some industry provider data centers, to put in these cores and edge devices. Part of what we're looking for, and my plea to you is, we've talked to industry folks who are willing to give us, a couple of rack units of space to put a node. That would be immensely helpful so we can grow this footprint. So this is currently where we have equipment. These are a bunch of universities and regional data centers. So what is a fabric node? So we have this really beefy terabit core, which is programmable. Then we have a bunch of core and edge nodes. All the core and edge nodes have GPUs, they have compute, storage, and programmable network capability. So really beefy GPUs. You can use, if you want to program using P4, OpenFlow, processing speeds up to, I think we're doing up to 4 times 100 gigabit speeds. And the key is people can access the hardware directly. You can get to bare metal directly. You can bring your own equipment. You can use our Metronome cards. You can use GPUs to really do the experiments you need. The testbed will connect with cloud testbeds. It connects with things like Google and Azure. It connects to supercomputing centers to really make a huge plane where people can, on bare metal, wherever they need to experiment, they can do it. And you can see the cores are mostly at kind of like Equinix type facilities, and the edge nodes are primarily at campuses or labs. So one of the things that's near and dear to my heart, I'm a measurement person, is to do better measurement. And I feel like this is where we could use input over the next 2 years. Of course, there'll be the traditional measurements that network people want. We have something called packet GPS, where in theory, at any point in time, you should be able to see during an experiment where your packet is, microsecond level measurements. We'd like to get to picosecond measurements. We're not sure people want that, but really figuring out how to do time synchronization across this humongous platform is really challenging, and it's really expensive. So any ideas about measurement or what people kind of real operators need for measurement is very helpful. The optical ones are fairly easy. Other types of measurements, we're still kind of wrestling with what's the right thing that we think people want. So real briefly, I won't go through all this, but what Fabric is and what it isn't. What it is not is it's not intended to be a brand new way to send your packets. It's not intended to be operations or real world processing. It's not intended to be long-term production. It's not intended to, if 5G dynamic slicing for first responders come through, it's not intended to support first responders. What it is intended to do is experimentation that says, we validated that this is the right thing to do during a crisis, and we've tested it in all sorts of connectivity and locations. Now that it's ready for production, I'm done using Fabric. But the intent is really to have an everywhere programmable network. So there's not like this dumb core smart edge or vice versa. Everything is programmable. And we intend it to be extensible, to connect to a bunch of facilities, and everybody should be able to use it. So it's going to be very easy to get an allocation. It's a little bit similar. Many of the folks came from the Genie environment. If anybody was an experimenter on Genie, I was not, but many people were. And we're kind of taking the best of that and ditching the worst of it. Some of the science design drivers, one of them is first responders. That's at Georgia Tech. They do a lot with first responders down there. We're doing some machine learning in the network. It's definitely not our best, most fleshed out case, but we're trying to do malware detection, anomaly detection on the WAN using machine learning at scale, which is pretty challenging. Named data networking, which some people believe is the future after TCP/IP, and of course security. So the construction timeline, the majority of the funds are for construction. So basically, the first 2 years are really running the fiber, putting equipment in, making sure it works, getting authentication down, with our intent to start kind of late in year 2, early in year 3 to get people on board this test bed. So this is something where we want to get feedback early. We're doing a community workshop in the spring to make sure that our vision and our progress is appropriate. And for way off base, it's a good time for people to say, that's not the kind of measurement we need or want, but we need more of this. We're looking for a really vibrant community. Facility partners, people who are willing to host equipment, people who are interested in experimentation that we might not have thought of, regional providers, network providers, government agencies, industry. So if people are interested, this would be very helpful to keep in touch with us. I'll show you our webpage. It's easy, whatisfabric.net. We have all sorts of things about where we're giving talks. There's a Slack channel. You can volunteer to put a Hank, which is not a great name. I guess it's like if you sew, I guess you'd be familiar with the term Hank. But that's a node. If you want to host a node, even better. Or if you want to talk about your research. So that's my very quick presentation. Come talk to me during this conference. We would love to involve more people in this.
And we have 5 minutes for questions and comments.
Sure.
How do we get involved?
If you go to, there's a couple things. One is a very light mailing list. So we have a Twitter feed. We have a mailing list here that you can say if you're an experimenter, if you're an academic, if you're industry. It's kind of a light mailing list. There's a lot of information on that page. You can give us feedback. We can come talk to you. We have a whole team, an outreach team that I'm part of, where literally that's what we do is just get in calls with people and get feedback. And if you want to be an experimenter, we put you on a list. So what we do is you set up a call with us right now because it's early days. We make sure that we are satisfying what you need for experimentation. And then early in year 2, which would be next September, you'd be available to come on the platform. So you could get an allocation. You just say, I need about this much GPUs. I need this. You may not know what you need, but sign up there, and you'll be in our mailing list, and we'll have your name, your organization, your area of research would be really helpful, and that's how we'll get in touch with you.
On the graph that you had the orange. You had Chicago connected, and I saw Illinois, Champaign. You had Chicago connected to. Is it connected to? Is that Chicago? Yeah.
So our connection's at Starlight, which is a big telco hotel downtown. It's hosted by Northwestern. It's an old Ameritech facility.
Oh,
so
yeah,
Starlight's
Starlight.
a big international facility. And then NCSA has a node just because they're NCSA.
Okay. So you have any universities connected there? Because we brought Internet 2 over to 350 CERMAC, the world's largest data center over there. So on the Internet 2 side, so you have any universities connected from Starlight back?
So Starlight is the Chicago connection. What we are now working on is getting universities. So universities can connect a couple ways. They can go through commercial internet. They can go through Internet 2. So like here, if you're on campus, you would use your Internet 2 connection, which would physically go up to 350 CERMAC and then go to Starlight.
Okay, so we can connect you through Starlight. So are you trying to run some dark fiber now? You saying in town or to other research facilities? Or?
So Chicago has a really rich dark fiber footprint. What we would like to do is put more nodes within Chicago, so ideally on campuses. So right now our major core is in Starlight downtown. Ideally, because there is so much dark fiber in Chicago, and we have a node down at U of I, we'd like to have one at IIT, we'd like to have it at Northwestern, whoever wants to, definitely, Wisconsin, the Midwest area. So if they would host a node, certainly if they have Internet 2, who is a partner of ours, and they're providing bandwidth for this, they can just get to the instrument through Internet 2.
Well, that's great, because I've got dark fiber coming right in front of this place. It's not connected, though. It has to go to 350, though. But, yeah, we can do a node here.
We should talk then.
Yeah.
All right, so thank you very much. It's 10:30 now. I want to do it. But I would not say Hank, I would say a pole. Right? A pole watch. So we have break now, 10:30 to 11. At 11 o'clock, we have a keynote. The keynote is at the other end. Please be on time so that you get the full I hope we're online. So this is the afternoon session of the IPTCom track. And without further ado, we're going to hear the cyber topology model from the Texas 2000 synthetic electric power grid, and Anna Goulart from Texas A&M is going to be the presenter. So thank you.
Thank you, everyone. So I learned a lot this morning, and I hope you can learn a little bit from my work as well. This is actually the work done by a lot of students, as you see the authors here. Yeah. So the first three authors are my undergraduate students. They're graduating next year, and to be honest, they did most of the work. Then we have 2 PhD students, and the last 3 are professors. And we learned a lot too from them. So this is a very applied work. It's related to cybersecurity, but related to the smart grid. So I'll tell you a little bit more about it. So our goal is to protect our electric grid. As we saw in California this past week, if we don't have electricity, it's a disaster. So we depend a lot on electricity, but the physical system, the electrical grid, is very dependent on the communications technologies, the cyber component. And so this is where we come in. So I'm working with this power group from Texas A&M, doing the telecommunications part, and our goal is to learn how to detect those problems that may originate in the cyber, in the network, to a cyber attack, or it could be even a physical problem, and then we can see, can we detect that from the network side? Could we have done something to improve? So there's also mitigation. But I think the main goal for now is modeling and detection that we're trying to do. So here's a picture from our proposal. We were very fortunate, so we can support and sponsor the work of all these students because we got a large grant from the Department of Energy. It's a 3-year grant. So we are completing our first year. And the name of the project is Cypress. So we found out a nice name. So Cypress is a next generation cyber physical energy management system. So as you see on the left side, on the left side of the picture, on the top we have the power system, and on the bottom I would say the networking, how everything is connected. So this is the first step. We want to do the cyber physical model of this system, and then through simulations and also some experiments, we're going to verify what happens, how dependent when the physical side is from the cyber side, how problems in your network can cause problems in your power side. And the good thing is that we are working with industries as well. For instance, some industries are mentioned here. Vistra is a very large generation company in Texas, in Dallas. They purchased a lot of companies also. They have natural gas, wind. They gave us all their data. They're giving, not the data, selected data, but they're giving us their data, the physical data. They have these historic databases, but then we're going to get those PCAP files as well. We're going to get real, like, Wireshark files, and we're going to try to see how the problems they had were related in the network and the physical side. We also, so the second part is this, that we are doing some experiments with real data and verifying what happens, and hopefully we can do the detection. This is something the PhD students are doing. They're doing some machine learning, of course, to see if they can do some methods to improve the intrusion detection systems that we have in the networks. And finally, some mitigation, but both on the physical and the power side. So this loop So this is the main goal of our project. Hopefully, we can do this in 3 years. It's a lot of work. I'll show you one thing that we decided to do. Because, for instance, to get data from industry, we have to sign a lot of NDAs. And, for instance, the project started in October last year. We just got the data from the company this week, like last week. So it took a year to get the data. So we said we needed to find a model, like a test bed. So we found out that we already have a model for the power grid. So we call this synthetic model for the power grid. It's done by one of the professors. He was a professor at University of Illinois, Urbana-Champaign, and he moved to Texas A&M. So I think we stole him. So he created this Texas 2000 bus model, has more than 2,000 substations. It's very interesting. He told us how he created the model. He had some knowledge of the power grid, but of course we cannot give this knowledge away. But he made up some locations using post office locations to create the substation. So he had zip codes. So it works well because the more urban areas have more, like the grid is more dense than other parts. So it's very interesting how he created the synthetic model. But when I went to his workshop, I asked, what about the communication side? Do you have any communication information for this model? I said, no, we don't. And that's where we came in. I said, okay, we can create a network for you. Based on this model, we are trying to create what are the routers, the firewalls that goes in the substations. We have relays. The relays have IP addresses, so they control the circuit breakers. We are also emulating, one thing he doesn't have in his model is the control center. We created a utility control center. That's where the SCADA system or this energy management system is, sending commands and getting information from the substations. And also we had to create, I used to call a regulatory agency, but they corrected me. It's called balancing authority. So I think every state or region has, as I suppose, if you are generating too much power, or maybe during the summer, everybody's using their air conditioners, there's a balancing authority that tells the utilities you need to produce more power, or you need to make sure the grid is balanced and won't have any problems. So we modeled also the balancing authority. In Texas, it's called ERCOT. And this picture here is actually, we're fortunate. We have this lab at Texas A&M that emulates a utility control center. We have a software from General Electric that is really emulating a real control center. I'm sitting on the back there. These are all students. But it's hard to make this work in real life, like we're emulating a real utility. So this is where we come in. So we have this model with several substations. So we have nodes and links. The links are transmission lines. So we converted this to a JSON file that has nodes and links as well. So this is initially our one topology of one part of Texas, the cyber model. And I found out this language, it's called Cyber Physical Topology Language. The original paper they did in XML, but actually the idea is very interesting. Like you model your network, but you add information about the power side. We add information about the substation. We add the application protocols that are being used, all those industrial protocols, such as DNP3, Modbus. So it's a hybrid. It has network information, most of it, nodes and links, but it has information about the power side as well, which bus it relates to. So you know if there's a problem in the network, we know which part of the substation is being attacked or which part will be at risk. Maybe we can isolate the physical part. So this is the main idea. So here's a picture of our model. It shows only one substation in the bottom. And I have the firewalls. I know a lot of people thought, oh, we have to put the firewalls, the routers first and the firewall. But actually, this is fine. The main thing we were worried about is one part we didn't know about the relays and relay controllers. So we got a lot of information from a company called Schweitzer, and then how they model their local area networks. And of course, the substation needs to have a corporate network, like card readers, video cameras. These are not the OT network, the operations network. The OT network would be the one with the relays here. And then we have the operations center. There's always also a web serve, a demilitarized zone that must be open to the public. And the protocol between the EMS, the energy management system, the substations that we are using, the layer 7 protocol is the NP3. But then I learned also about a new protocol between ERCOT, the regulatory agency, and the utility. We have this ICCP, it's Intercenter or Intercontrol Communications, or Intercontrol Center Communications. So it's an application layer protocol, and it's not protected. They don't run over TLS or anything like that. Of course, it's a very private network, very secure, like they have VPN. But I'm learning a lot about a lot of security that we use. First, we did SIP over TLS, HTTP, but these protocols, they are not using over TLS. So I see a lot of areas that there's a lot of opportunity if someone learns more about these opportunities for attacks. So overall, so there's a similar picture. One thing that I was going to tell you that, so this network that we created, so actually it needs to work with a power simulator. So the whole point of the synthetic model is that we are using the simulator called Power World. So we have to run real-time simulations. So we do the model, and we have to enter our model into the simulator, but it's not a discrete event simulation. It has to be real-time. So it goes back and affects your breakers. So things will happen. So we are trying to really create this cyber-physical simulation. Okay. So so this paper is mainly about the phase 1, creating the model. And we are still working on it, but we are already doing some simulation that I'm going to show you. But just to create the model, so we import data from Power World. So we have lots of tables about this Texas electric grid, the synthetic model. And then we have a Python script that reads those Excel files, and we create the JSON information. Similar to that CPTL language, the cyber-physical topology, nodes and links, and lots of attributes to those links. And one thing, so in our paper, we didn't show these. So we are using the simulation, and we tried a lot of simulators. We tried NS3, real-time simulation, but we ended up doing this core simulator. I don't know if you ever used it. I think it was developed by Boeing, and then it's a common open research. It's actually an emulator. Yeah, so we have virtual machines, and these talks with Power World, our power simulator. And we're working on a Python script that imports the JSON file into the simulator so it can build the topology automatically. So this is the current stage. But for the paper, we just had the cyber model, the JSON, and that's what we presented here. So this is the cyber model, the Python classes that we have. The main thing that we need to see is like we have nodes and links. Also, we have substation information, control center. And one thing I forgot to mention, one requirement that the industry asked us is to model different businesses. So we have multiple utilities. For instance, in my city, I live in a small town called Station Bryan. We have 2 small utilities. So they wanted us to emulate also different utility control centers, different businesses as well. So we all put this in the JSON file. And one thing that we are working right now, we have to add the firewall rules. So we have an attributes part in our JSON. So we're adding all the rules, which protocols are allowed, like DNP3, ICCP, Should we allow DNS? And then I was talking with someone. So we actually we modeled this network initially to get some of the firewalls and to test. We use Cisco Packet Tracer. And when my student added all those rules, nothing worked in the network. I mean, she blocked everything, and then we have to see how a real utility. And we are having an industry workshop in a couple of weeks, and we're getting feedback on this topology that we are using as well. But the firewall rules, I think, is the most important that we are working to implement. So we can do assess the vulnerabilities of the network. So here's the use case. So Texas is very big, so we did the southern part of Texas, McAllen, so it's at the border with Mexico. So we had about 70 substations, and as you can see, we have the geographic location. We import from those tables, and then we created the network for that region. We created utility control centers, and we created substation with all those relays with IP addresses and routers as well. So it's a very practical work. And then, so the Texas model didn't have the utility, so we did some, we used that SciPy, and then we did some clustering, the workstations that more interconnected, and then we chose the central point to be the utility, and the regulatory agency, which would be ERCOT, we put in our campus. So our university would be the regulatory agency. But our goal is to do the whole Texas. But then we learned that our model is not very scalable. So that's all the scalability problem that we have in networks as well. But anyway, so as you see, just for that region, we generated like hundreds of nodes, routers, firewalls, all in this JSON format. The pictures that I show in the right, initially we were trying to use Splunk because it can, because of JSON data, and it does the queries really well. We could do we tried to do the topology, but we found out that Splunk to do topology is not that good. It's not made for doing topology. We may use this for other things, but the pictures that you see here, for instance, importing from our JSON, we have a substation, we have the router firewall, and we have the OT network, the operations network with the relays, and we have the corporate network with the card readers, video cameras, some desktop for the operators. And at the bottom here would be a control center here, the EMS server, and several utilities connected to it, either through firewalls. But the way that we are learning how the utilities really have those, most of them is star topology. They have one firewall on each side. They don't advertise their routes. So it's a very closed network. So we are learning. So we are using this star topology to do. But now we are learning also that the substation, sometimes we may have inter-substation communication. This is something we don't have in our model. So all goes through the control center. But I think then it adds one more, maybe one more firewall or one more area to look after when you have inter-substation communication. Because you may have a small substation that uses a bigger substation to go to the control center as well. So a lot of new networking things that I'm learning from the power side. But anyway, so our work was mainly modeling, but now you know about our project. And then, yes, Carol? Oh, 3 minutes, yeah, so we're almost done. So I'm finishing. So one thing, we need to address the scalability because we have more than 2,000 substations. And our code, our JSON is huge. And we wanted to do something that we could do a zoom in and zoom out in our network. Because actually we wanted to emulate maybe even a blackout in a large region of Texas. So for this, I may not need so much detail about each component in the substation. So maybe just how they are connected. So we are trying to use this CPTL language, cyber physical topology language, to do the zoom in and zoom out as needed so we can address the scalability. Another thing, so we are working on the firewall rules, and we want to simulate several cyber attacks, and a lot of things that people follow. They want us to do something like, I don't know if you've heard of the Ukraine attack, that was several attacks combined. And that's one of the goals. And just on the last minutes, this is not in the paper, but I want to show you a little bit. We did a demo for the DOE last week, and we had the simulation in the middle. You can see the core emulator. So the red, so let's see if I have my mouse. The red is the cyber attack. So we had a man in the middle attack, and we were doing a replay attack of some DNP3 packet. And it goes to the control center, but then we were able to show whatever that unreliable command was, it's an unreliable measurement, like a node measurement was sent to the control center, and then we put this in the power world, the power simulator, and made the grid unstable in some parts. So we demonstrated just one substation and one cyber attack. But now I think we can move on to do more substations, a larger scenario, and also address the scalability of the JSON model that we have. Yeah, but this is the latest, a couple of weeks ago we did. Yeah, but that finishes my talk. If you have any questions. Yes.
You said that you used Marshall PCAP file?
That's right.
What were you looking for in the PCAP file?
So even in the simulation, we were, so the control system, we got their data, and then in the emulator, we made this data look like a networking data. The PCAP, currently, suppose my student is using the PCAP files. Actually, he's doing a man-in-the-middle attack that he's changing the data. Yes, so I think he's using a tool called Scrappy. I don't know. So you can change the PCAP file. So, and this may be considered a false data injection. So we changed the PCAP. And as I told you also, industry, the one of the collaborators in our project is giving us their PCAP files for several months, and also the physical files, so we can do some correlation and see if we can learn. But yeah, Wireshark. It's like yeah. Carol,
Yeah, so I hope you're able to stay here tomorrow because we have another speaker from Amber, and she is also working on grid
Oh, really?
networks, and I think it's going to be mostly related.
Oh, that's
so,
good. Yeah.
for the Amber.
I'll keep an eye. Yeah. Yeah. Thank you, Carol.
It's involving connecting grids with the idea that how a grid, a microgrid could stay up while the larger backbone and the larger networks are
Going out. And this is all about resiliency, right? Yeah. Mm-hmm. That's good. Any questions? Yeah.
Yeah, we have about 4 more minutes, actually. I try to break it so
So, yeah, questions. Yeah. Thank you.
I noticed that you put now service at the top, the fact that you simulated.
Yeah, yeah.
Is that because that's the most prevalent, most common?
Come on, yeah. And so delay, the timing information is very important in power networks. So if you have even a mild denial of service attack, somebody causing traffic in your router, injecting traffic, it will cause delay in your packets, in your commands. Suppose you get some you request for some voltage or current readings from your substation, but it comes with a little delay. It may cause an instability. So the timing of these power systems are very important. So any minor denial of service attack, yeah. And in the Ukraine attack, actually the denial of service attack was in the call center. I don't know if you know. So they attacked the grid, there was a blackout, but then customers couldn't call because the call center was attacked as a denial of service attack. So it's all, yeah, it can be a combination, yeah.
No, I do have a question. So I'm interested in whether this same kind of modeling technique could be used to on other types of threats to networks. You mentioned the wildfires to begin with, so it occurred to me that both physical threats, not cyber attacks, but just physical damage to the network, and also possible just bad management of the network, because a lot of times outages
When we see outages in networks that are caused not by a cyber attack from the outside, but from poor maintenance, from somebody making a programming error or doing something on the inside, often unintentionally, that has the same impact.
Yes, and it can be so. So the idea is that we also can detect human failures, the mistakes that have been done in the network. So this company here, Vistra, that gave us the data, they are not only interested in cyber attacks. You know, they think that their network is well protected, but they wanted to see if we can correlate any failures in the power system with some type of failure in the communication system as well. Yeah, so it could be any type of problem. Yeah, that's a good point. Yeah. Yeah.
So now that you were saying that a student was doing a man-in-the-middle attack,
Yeah.
and so if on this data you all get it to be successful that you can do a man-in-the-middle attack, what will you all be doing so that you can't do a man-in-the-middle attack, you know, to make your data safe?
Yeah. So first of all, we're assuming the attacker has already infiltrated in your network. Sometimes they use maybe phishing and get credentials. But right now we are looking more at what is the impact on the physical side. So that problem, that this attack, so how can you detect if that breaker opened and it was not supposed to open? Can you go back to your network and find out, look, somebody is sending bad commands, things that were not supposed to be there. So right now, we are just doing this observation, what happens in the physical system, but hopefully we will learn how to do mitigation and maybe isolate one part, maybe like the microgrid, so the problem doesn't spread to other parts of the network. Yeah, but it's very interesting. So, yeah, sounds good. Okay.
Thanks very much.
You're gonna have to squeeze together, keep them shoulder to shoulder.
Well, we can spread beyond the table.
Okay, we can do that.
Right.
We can get rid of the flowers, you don't need that.
You put it back in the water. So you want the moderator could just be standing.
Yeah, moderate over there. Burger, oh, you.
I'm sorry, we took out the burger in the middle.
Where's the meat? She's got it, see, look at it.
Is this like the pea and shell game? Yeah, that's right. No, it's my original was burger.
A double burger.
A double burger. That's right. I was a double burger. That's right. That's right. Dr. Burger. Yeah, that's right. Well, I did my Belgian cards were, de hair. I didn't have my PhD yet, so de hair engineer. I did have an engineer degree, legal engineer degree.
If you want to sit down, get tired of standing. Oh, you could.
That's right. Yeah, that's right. Right.
Test.
Yeah.
Why don't I just sit here and...
Fireside chat.
Yeah. Well, actually, can we fire it up?
No.
I'm going to turn this off so people.
Yeah, because it's nice and
Yeah,
warm.
I think we should turn.
It makes the pictures better.
Unless you put a simulation of a campfire.
That's right. Yeah, that's
You
right.
know, the Christmas, U-Haul.
That's right. Yeah.
Okay, he'll put all
Okay, so let's start. So we have our panel on ethics and technology. And what we want to do, we want to talk about ethical implications of computer science and the development and use of technology and on how technology affects the rights and obligations of individuals and society. And I think that's quite a broad topic. We are very lucky to have a number of renowned panelists. On the panel, computer scientists who have a lot of experience in their field. First is Henning Schulzrinne. He's a Levy Professor of Computer Science at Columbia University. Eric Berger from Georgetown University. He's Research Professor of Computer Science. Then we have Lance Fortnow, the Dean of the College of Science at Illinois Institute of Technology. Anita Nikolic, a researcher in cybersecurity who is a visiting fellow at Illinois Institute of Technology. And Vijay Gopani, who, if I understand this correctly, initiated this panel, which I think is a fantastic idea. He is a chief data scientist of Whale Systems, and he is an adjunct professor at Illinois Institute of Technology. So thanks everybody for being here and talking with us about ethics. I'd like to begin with asking you more about your own field of research and about what you think are important ethical issues in your field, because you are the specialists. Yeah, maybe you just want to begin.
Let's see here. So I'll broadly take my field to mean networking and related internet type of systems in that. So I think the basic ethical issue is that we're essentially dealing what has become clear in other areas it's called dual-use technology. So I don't know if that term is widely used, but my notion is that this is typically used for export-import type issues, where a technology can be used for civilian, generally taken as good purposes, and it can be used for military purposes, as in can be used to heal and to kill if you want to take it to extreme pace in that. We didn't used to think of the internet that way, in the sense that the emphasis was always on kind of the good part. Presence of the internet would improve things in a variety of dimensions in that. And that is no longer, I think, a sustainable fiction. And so the ethical issues that often the amplification effect that the internet allows seems to be just as good, if not better, of amplifying some of the worst human tendencies than it is to amplify the better of angels among us. So I'm sure we'll get more into detail, but that's kind of my broad thing, is namely how has the internet changed as an amplifier, really, among actors that we don't want to amplify.
And thank you for reminding me of the interest in that. One of my students graduated 2 years ago, and his thesis was literally on dual-use technologies. However, his thesis was in science, technology, and international affairs. So he was in what we call the School of Foreign Service, which is our international affairs school at Georgetown. And I think that's also an important thing is, and I'm sure Lance, you're probably looking at this kind of stuff too, is we don't think anymore, we try not to think of computer science. We try to think more broadly. So like computer science and international affairs, computer science and business. And some of these issues are new. So, his investigations were into tools that are used for detecting malware on your network or detecting dissidents in your country. Same technology. The technology doesn't know what's right or wrong, but it's how it's used. But yet, his formal training was in like chemical warfare, where precursors to, the poisons are, and bombs. Phosphorus is fertilizer, dual-use technologies. And so looking at how, basically the things that are the same, but also the things that are different from the new technologies that we're creating, and the realization that it's not this scary new thing we don't know how to deal with. A lot of it actually fits into our existing norms, and kind of like the philosophers have worked out what's good and evil, 1,000 years ago. We might want to look at some of that stuff.
So my research background is actually theoretical computer science, and I have an advantage there in that everything I've done has no practical value whatsoever, so that's less ethical issues.
You said that.
I spent 7 years as a department chair in the computer science department at Georgia Tech, and now as dean here. And you can't help but think of all the ethical issues. I mean, it's just so many to go around. Probably the biggest is just that for many years we've not thought about them. We just kept thinking of the goal was to make computing as good and as powerful as possible. And now, I mean, I still think that's still a great goal because there's a lot of great good that comes from computing. But we don't often stop and think, and we're starting to do this now, but we haven't done it for too long, stop and think of what actually is going to, the effects of that. And probably the one that I've been the most interested, I mean, there's so many issues, but the one that I've been the most interested is what's the future of work? What's going to happen as we get to the point that we can automate a lot of jobs that are out there? And not just simple mechanical jobs that maybe we can get robots for, but, good, I mean, a lot of middle class jobs that are out there that just we might be able to automate away. What's the world going to look like when that happens? And that's something that just we're still trying to figure that out, and there's no great solutions as we try to explore that.
So I always tell people I work in this gray area between kind of the academic world and the other world, other side of security. And I've always been in the middle, and that makes it really tough. Security research is really tough for academics because there are lots of different rules. Computer Fraud and Abuse Act, DMCA, there's all sorts of structure about what you can't do, which makes it really hard to legitimately do security research. It makes it really hard if you are an average person who's really interested in security, who wants to help society and expose flaws in things like pacemakers. It makes it hard to do that kind of research because there are so many limitations on what you can do. So kind of all the ethics that surround that are still, they're being magnified now with all the different IoT technologies. So what concerns me is where does security research fare? Are people going to really take the risk to do this if it means they may lose their jobs? And in academia, that's a very significant challenge.
Thanks. Yeah, so I don't think I can add more than what my distinguished colleagues have said. I mean, I think one thing that I find fascinating is we as technologists create the technology hoping that it'll do change and that change will be good. But many times it doesn't quite turn out that way. I have a couple of examples. One example is how many of you now, when you talk to your bank records your voice and say that they will use it for fingerprinting, for audio fingerprinting, right? So typically I tend to say I don't acquiesce to it. And the reason is because A, it's easy to mimic somebody. You've all heard Dana Carvey do George Bush if you're of a certain age. So it's easy to mimic somebody, but more importantly right now, just taking a few seconds of your speech that's being recorded right now as it is, and extracting the phonemes from it, we can create custom voice. And if I do that, and this custom voice says I'm Vijay Gurbani to my bank, and it matches the fingerprint they have, voila, right? So that's fascinating to me about the technology and its implications. And the second thing that I find fascinating is this whole notion of having these AI, intelligent, so to speak, beings, and the idea of nature versus nurture. We all know that twins put in different backgrounds will evolve differently depending on the nature, right? But an interesting experiment occurred when Microsoft Research released their bots. Ty, I believe, was released on the Reddit news group. And the exact replica of Ty, same code base, was released in China. And the bot that was released on the Reddit learned how to curse, learned how to be racist, learned how to do everything that it shouldn't.
In like 2 hours.
Right. And the one in China didn't. And the question here is not, is obviously these things will pick up what they're told, what they're taught to a certain extent and told. But the more interesting thing is where, so I mean, we could go further down this, but that to me is fascinating, to have these genetically similar components exhibiting vastly different behavior depending on the specific environment they are in. So I think from a computer science perspective, there's lots of interesting things to look at in ethics.
Yeah, thanks a lot. There's really a lot of ethical issues already. So you had this example with the bots and with a machine learning question basically, and with a question, why do they end up so differently, and why do they? This is the algorithmic bias problem, isn't it? The point that some bias may come in a system without being actively coded, but just implicitly ends up there, and that's one of the huge ethical issues around networks, around artificial intelligence at the moment. And maybe some of you can contribute some more examples from your experience and talk about the problems going along with this.
Well, actually, I'm going to make another plea for anyone who heard my earlier keynote. I'm going to say the same thing again. So I moderated a panel at University of Colorado, and it was mostly lawyers, but it was on algorithmic bias. And the thing is, the lawyers have been doing internet-y stuff and computer science-y stuff kind of new, but a lot of the policymakers were just like, oh, the algorithms are biased, so can't you program the algorithm to not? And it's like, no, these are machine learning algorithms. This is not that we've programmed it. And so the plea is to be involved, brief your state legislators, your members of Congress, to educate them, not this is good, this is bad, but just what kind of the technology is about. And then we can have all the nice research of, well, how do we correct bias? And I was saying this 20 years ago, so long before I was a regulator. But the reason we have regulation is because the free market didn't work in some respect. There was a monopoly we needed to change, or some investments wouldn't be made if we didn't. And if you look at bias, I guess the word bias is biased because, well, this is the training data. This is what people did before, so we'll do what people did before. Oh, but we don't like it. So how, a good research thing is, how do you introduce bias? But it's a different kind of bias.
So one thing is the regulation afterwards. We have the system with the bias, and then we have the regulation, which may be a really good idea. I mean, I agree. Another approach could be to try to avoid bias and think about how do we feed the system, what can we do? You wanted to.
So let me just maybe amplify that a little bit. I see two things happening that are here. Namely, one is where we've had opaque systems that were human-driven but opaque. And I'll give two examples. And now these are somewhat being automated in some sense, and so it is both now easier and harder to see that one. So I'll give you two examples that are close to kind of more academic realm, what I'll deal with, namely admissions to college admissions and job interviews, kind of very high stakes decisions that largely, until fairly recently, were where my guess would be, anybody who's been close to the process knows that A, they're biased, and B, they're arbitrary. There is a fair amount of, we looked at master's admission at Columbia, and we found that all the numeric inputs that we typically use in that had very little predictive power as to how well they did in the program. And job recruiting has been traditionally known to be, even if it was no computer involved at all, it was biased in a variety of very well-known bad ways, racially, by gender, as well as just by other less legally protected dimensions in that. And we're now making that explicit. To some extent, I think that's a good thing. Because we now have a record of, we know the black box in the middle, but at least we know what all feeds in it. So for example, we know that whether the candidate had a spoken accent or not might not have been part of a decision. So we can maybe rule out that that mattered, maybe indirectly it did. And so that is, the question is, what can you do about it? And one is probably a humility recognizing that many of the decision processes that we have not automated in the past had more randomness in added more randomness in life than we probably were willing to admit. Where there was a notion that this is a fair process, whoever got into Harvard, Yale, whatever, deserved to be there, whoever got the job deserved the job, in that, leaving some bad actors aside who got their cousin or a nephew in, and that worked. And we have now much more, and I think AI forces us to be much more humble, that many of these processes are inherently biased, simply because there's a notion of what bias means. In many cases, I think it was criminal justice, where depending on how you define bias, you get very different results in what's the metric you use in terms of, is it plain racial bias, is it outcome-based bias, whatever it happens to be.
Just a quick short comment. There's an excellent book by Kathy O'Neill called Weapons of Math Destruction. My advice is, if you haven't read it, go through it. And one of the points that she makes that's very pertinent here is the fact that we as humans have biases, but we learn to retrain ourselves to eliminate those biases. And one of the things that we are seeing is that these models are put out with biases, but there's no feedback loop to go back and retrain them to make them any better. In the absence of such feedback loop, we'll have to live with the decisions that these models make, as biased as they might be. Oh, that I don't remember. Don't put me on the spot, Eric.
So, like, one of them was whether it was correctable. Another one was, did it have mass effect? You know, like if it affected a person, probably not a big deal, but if it, could ruin it. But there was a third one as well. I can't remember.
One was...
So definitely read the book and come back to me.
It's a really
That's your
good
homework
book.
assignment.
I agree.
Weapons of Math. Is math.
MA of math destruction, not of math, but of math, of mathematical destruction, yes. So I think there are two aspects. So one is the systems, they tend to perpetuate the current situation when you feed the system with white male people being more successful than other people. This is how we end up with. The other is that you mentioned this, the black box thing. We don't really know how the system comes up with a decision, and if all human beings, as human beings, we have biases, but this is the gut reaction, but then we start kind of deliberating about it. We start thinking about it explicitly with language, we start a rationality process, and then we may be able to come up with a deliberate decision, a deliberate form of behavior. We may or may not. I mean, we all know there are problems. With a system, we only have this black box. We have only the kind of gut part of it. It's difficult to understand. I think that's a huge problem. We kind of rely on it and don't really know how it came up with a decision. So how do you think of this, especially, yeah?
Well, I'm going to start. So, I mean, there's a lot of issues you're unpacking there. So first of all, a lot of modern machine learning techniques produce, they learn from data, but what they produce is they produce a system which is very hard to understand what's going on in why it's making the decisions that it's making. And there's a trade-off there. You can you can learn in ways that you'll understand what's happening, but you're likely to have far less accuracy in the results that you have. And companies tend to make money off the accuracy, so they tend to prefer that. There's also the issue of if you have something that's fully explained, people can take advantage of it. People can, like if you knew how a search engine ranked web pages, or you knew how a jury system decided what an outcome, you know, how much money someone would get in a lawsuit, then people would manipulate the inputs, you know, just like the way that people manipulate their tax returns, because you know exactly what the rules are, so people will work their income to get the best outcome. And there's some negatives to trying to fully understand the system as well. I think a lot of it comes from the data. I mean, it's very rare that I think someone actually programs biases directly into algorithms. I think most of it comes from data. You know, if we learned biases, then the machines will learn them as well. And, you know, oddly enough, it's strange because a lot of these things were developed to avoid biases. People were saying, listen, human judges, for example, can be very biased. So in order to avoid biases, we'll go to a very algorithmic approach that looks like it avoids biases. And sometimes that works, sometimes it doesn't. I mean, one of my favorite stories has nothing to do with computers at all. It's how compositions of orchestras. So orchestras used to be almost all male. And what happened was there was some sort of conflict of interest. There was a conductor whose, I think, son or someone like this wanted to audition for the orchestra, and they wanted to eliminate the conflict of interest. So what they did was they had a curtain, and they had people perform behind the curtain, so you couldn't see who was performing. And when they started doing this, all of a sudden there were a lot more women being put on the orchestra, and this is now standard procedure now. You always when the major orchestras do auditions, they do it behind a closed curtain, and they're very careful with noises from shoes or whatever that might give away the gender of a person, and you end up with a much fairer system. So sometimes, oddly enough, the right way to solve algorithmic bias is to remove the data than to add it. But even that's tricky because you can remove every marker that you think has to deal with the race, and machine learning is good enough to still figure out what the race is and discriminate against it. So none of these things have easy solutions. And it's not even clear what fairness means. You know, what is fair? And then there's different, is fair making sure that we have exactly the same racial breakdown as society does? Or is fair means that we ignore the race and we just give people based on you know, what their test scores are? And the answer to both those questions is probably no. So these are incredible tough things. There are a lot of smart people trying to figure it out. The best thing I think we can do as computer scientists is frame the questions and then make sure that the policy people understand what the challenges are and what the tools are out there that they can rely on.
Yeah, this was a strong plenary towards black box, in favor of the black box. Do you all agree? Or, I mean, your example was a good one. I know this from the Berlin Philharmonic. This was exactly the situation. They only accepted male participants, and things change, yes?
Yeah, it's the problem, I think, is partially, and you made what a good example is, there are some things where it's probably relatively clear what the performance is. Trained musicians can presumably judge, leaving aside the gender issue, whether somebody is either qualified to play in the Berlin Philharmonic or not, just by listening to it. I wouldn't be able to tell beyond just a very basic level, but and probably in sports and some other disciplines, that's relatively predictable, for experts at least. The problem is that we've created a number of very high stakes decisions in life, and I mentioned two of those, but you can think of medical insurance, you can think of others, where I think the problem, and you mentioned it, is inherently difficult. And the problem has gotten worse because we've made decisions much more high stakes. So for example, and this is again one where in many European university systems, you don't have this gradation between kind of the Harvards and kind of the low-ranked state university in terms of where you went to university. Just, it doesn't determine your life future to that extent. So the admission process becomes much easier. You can still distinguish yourself at the university in a variety of ways, and you will do that, but it is not one, oh, if I didn't get admitted to a highly selective school, so a whole set of other opportunities are no longer available, and so you now have this inherently difficult problem. How do you tell, looking at an 18-year-old or 17-year-old, as to how they're going to do in life in that? And so removing the right decision, I think, in that case, to say you're asking a decision algorithm to make a decision which is inherently impossible both for a human and a machine. Thou shalt not do that. Just adding machine learning to that doesn't make the problem better. It just simply removes responsibility, as in they're no longer humans. You have to say, admission officers, you know to be fallible. It is now things that are more shifting blame, and my sense is often the use of these techniques is often to shift blame, as in the machine said it, must be right, no longer you can't blame the university president anymore, or whoever is eventually responsible for that.
Yeah, but that's exactly the problem, isn't it? In the end, nobody is responsible, or maybe the machine is responsible, or, I mean, who is responsible? Maybe with your example with the orchestra, yes, the male people behind, they were to blame, but maybe they should have reconsidered things. Maybe they should have come up with a better way of decision making. Yes, there is someone responsible, but with a computer system, who is to blame? Who is accountable?
Well, I mean, if Facebook consistently recommends certain articles, Facebook's to blame. I mean, that's pretty clear for some of these systems. If your insurance company jacks up your rates because they've aggregated and bought a bunch of data about you, put it in their algorithm and determined your car insurance should be more than mine for secret reasons, they're to blame. I mean, it seems to me that the accountability is there in terms of ethical and moral accountability. What's not there are penalties to force them to reveal what's inside their box, or to be penalized for charging people different amounts of money. I think morally the responsibility is pretty clear if you own a product.
So with your Facebook example, it's the company who runs the algorithms.
Well, certainly, yeah, because they're the ones that are they've selected what the training data is, they've selected what data they're making decisions on, they've selected all that infrastructure, and you by getting it for free, the premise is that you know, by their good graces of selecting these generous algorithms, you benefit, but they are so culpable for their own product.
Yeah, so I think the blame game is interesting exercise, but I think there's also a fact that, so let's take an example.
May I just say one sentence? Maybe the blaming part is wrong. Maybe we should also say who is to praise. I mean, there may also be a positive thing. We are so on the negative downside of things, but it's of course two parts of the thing. Sorry for interrupting you.
No problem. I think we're on the negative side because we are seeing too many of these law of unintended consequences arising. The case about that lady who was trying to cross the road on a bicycle that got run over by Uber. So here's an interesting thing, right? So what do we do when we as human beings want to cross the road and there's a car coming? Typically, we make eye contact with the driver, and there's some expectations that pass between us that the driver kind of either gives through a nod head, or through nodding his head or her head, or some unspoken communication tells us that, okay, I'll stop, you can cross. Where is that feedback in these automated cars, right? So did the automated car make eye contact with the lady? Did the automated car recognize that what was a bicycle was indeed a bicycle because the lady had handbags on her bicycle, grocery bags? And, we tend to assume that our data that we are going to test on is taken from the same distribution as the data that we trained on. Is that a good assumption? I mean, that's one of the reasons why you take a stop sign and you put a couple of Band-Aids on it, suddenly it's not a stop sign anymore. It becomes, drive at 45 miles per hour sign, right? Because the real world is far more random. The real world has much more context that needs to be assimilated in before a decision is made. And, so the blame game, I think, will continue for the short time at least.
I always have a kind of different view when it comes to self-driving cars, because there's always this discussion about being careful about the ethics of self-driving cars. But I want to make the point that while we've been talking, 5 people have died in this country by human driving cars. So often another thing that happens in computing is we feel like we need to aim for perfection to the point where we're not going to cause any deaths by a self-driving car. But when you have 30,000 to 40,000 people a year dying in car accidents, and computers never get drunk, drowsy, or distracted, you really have to think about when computers are saving lives, you have to be careful that you're not focusing on a few cases. I mean, it's tough because you don't want to see anyone die, but computers never get any credit, when they save a life. but you have to. These are very tough. These are very tough things to rely on, but to think about. But the real ultimate thing is how do we make the best of what we have. There's a lot of good that comes from computing, and how do we take advantage of that, realizing that they're never going to be, by very nature, machine learning is a statistical thing. It's never going to be perfect. And but how do we get to that point that we kind of accept its imperfections the way we certainly accept imperfections from humans to some extent.
I mean, the Uber example is one where, as far as I know, we all in academic have to deal with institutional review boards because it was recognized after some pretty bad outcomes that individual researchers have biases, and not of a racial or other kind, but of you're optimistic, otherwise you wouldn't work on, if you never believed that autonomous vehicle could save lives or make money or whatever, you wouldn't work on it in that. And that those biases towards optimizing your own objective function as opposed to some other metrics. And so one of the minimal things that I'd say is that commercial companies, as opposed to just universities, need much more external view of things where, so the question would have been, let's agree for a moment that long-term autonomous driving can save lives because it doesn't get drunk, it doesn't get distracted by looking at cell phones, whatever, in that, but we're far away from that. Because on an average basis, I think it's it's far too many deaths, but it's 1 death per million miles, as in most people will hopefully in their whole driving history never hurt or kill anybody. So the threshold is actually quite high. It's only a problem because people drive so much. So the problem that you had is you had no external review that said, well, yes, we agree that you should develop autonomous vehicles, but putting them out on the road and trying on real-life human beings is probably a bad idea. You should probably do some more lab testing in a simulated environment where, only Pac-Man dies, as opposed to a bicyclist. And we don't do enough of that, particularly for companies. There doesn't seem to be a requirement for companies to defend their decisions with societal impact to anybody but their board, maybe, who's clearly biased because they want to make money on the invention.
And actually, I would like to push back on why are we focusing on blame and not the thing? So we happen to have a real lawyer here. But what I would offer is, when us neophyte lawyer, David, us neophyte lawyer, or people who play lawyer, we think, oh, Congress passed a law. It's a law. Well, the thing is, it's not a law until a judge interprets it. It's not a law until basically somebody goes over the line and the judge says, yes, you went over the line. It's a cultural thing, and I guess the good, bad news, like we had the example of the Microsoft bot in the US and in China, and so we saw in different environments evolved differently. I could very well, having lived in Europe and imagine in Europe and having been to China a lot, acceptance of autonomous vehicles will probably be a lot higher in Europe because there's a belief that the government is working to protect you. In China, because it's a hierarchical, we're told to do it. In the United States, we also have to deal with issues like, isn't it great? The government will know where you are at all times. The government will know. In fact, here's like a difference in cultures. The government in the US will know when you go to a whorehouse. Bad. The government in the Netherlands will know when you go to the red light district. Okay, whatever, everybody does it, it's legal. And so the cultural mores, and the thing is, in the United States, the mechanism we have is not there ought to be a law that companies should have an IRB. Companies get sued. Companies lose. A judge says, yep, you cross the line. Companies say, how can I protect those? Why? I would like to think that universities have institutional review boards because we want to do the right thing for people. Oh, by the way, all of our government funding is tied to having an institutional review board to protect the funders, right? And so I think there's nothing wrong with saying who's got the liability, because whoever gets the liability is going to fix it. And yes, so Facebook is responsible, but they bought the algorithm, but they'll make sure that they buy good algorithm and they'll have indemnification. So for computer science, it's going to come down to you. You got to think really hard about what you're doing.
That's interesting. I was thinking, I'm from Europe, I was thinking, autonomous cars are so attractive, will be attractive to Americans because they will kind of increase their freedom, independence, do what they want, they will be more flexible, can do other things. Well, I mean, all of this. But I mean, I agree. If I understand, in my understanding, there are two levels. The one is the empirical thing, that the system has to be trained better and has to not confound a bike with something else, and so on, and all of this. And the other is the question how the system actually does make its decisions, and how values play out here, cultural values, moral values. And this seems to be a huge problem, or this is a huge problem overall, not just in autonomous cars and in all kinds of AI systems, how to build values in moral decision making, ethics. What are your thoughts on this? Is it necessary at all to build in values? I mean, maybe that's a way to start. Is it necessary at all?
So in fact, I'll put in a little IIT pitch, and I'll definitely put in a Georgetown pitch. So, when I got my PhD here, it was not, like a PhD in Java programming, right? It was specific research, but the goal was not just my thesis, but to go on and do more research, to learn how to do research and write it up and talk to people about it. It was about the process. And I think that is, the opportunity here. So should we be teaching how to create algorithms that have less bias or have purposeful anti-bias, which is a bias put in? Sure, but is that it? No. This is why, like at Georgetown, on the one hand, we in fact, it was a debate where, like when I did my undergraduate, everyone had to take physics at my institution. And so we had physics for normal people, we had physics for masochists, which is, you had to have placed out all of the calculus to be even eligible to take the class. And then, we had physics for poets. And the thing is, I was talking with our provost at Georgetown, is, the concern is, we've got to have ethics training. And so that, we have ethics for engineers, which is kind of like the physics for poets, ethics for engineers. And that the idea is no, not just. And we do have an ethics requirement at Georgetown for all students. But we've actually just started, and I'll do a shout out to Mozilla Foundation. We got a Mozilla Foundation grant to actually integrate ethical thinking. Because by the time our undergraduates go on and start companies or go on and get their PhDs and do whatever, yeah, anti-bias maybe will be solved, but there'll be another ethical issue and another ethical issue. So to get students thinking about, what's the impact of what I do, and how does that fit into my society at large, to get people thinking about that a computer science degree or an engineering degree is more than just, do I know how to program, but am I programming for good?
I do want to make a point to that, because I think that traditionally, and I'm not saying that the Georgetown one does that, ethics, if you look at the society, like IEEE and ACM have had ethics codes for decades, basically since their founding, I imagine, almost very close to that. And the performance, I'm guessing, I was not around and I was not clear of the history of it, was very much a individualistic ethics as a doctor and a lawyer might think of it. As a profession, you should, probably as civil engineers, even if your boss tells you to take some shortcuts on that load design for that bridge, you shouldn't do that because, or your doctor, and all these good examples. What these ethical things tend to short circuit is they tend to focus on the individual behavior of individual actors as to what they should do, which is important. I'm not saying they shouldn't think of it as, but that tends to completely ignore the societal consideration of what is going on. Namely, just like doctors now should not just think about, am I prescribing the right medicine, and wasn't it because the sales rep for that particular medication just had given me a free lunch, but also how am I contributing to a medical system that is broken in many ways, that does not provide universal access, is what we don't do a good job of is what is my responsibility, and collectively what is the responsibility at the societal level, be it liability, be it laws, be it equity, be it reducing the impact of high stakes decisions, all of these things that go beyond, am I doing a responsible job and not, kind of, in ACM we had risk culture, and it was very much of the, am I doing the right job as an individual contributor as opposed to more larger than one. And I think what we've learned is just relying on bachelor's degree recipients to put the burden of computer science ethics on their shoulders is asking too much and is asking too little.
So it's been a discussion like earlier about blame and about companies needing to be on top of things with their own review boards. But so maybe I'll go back to the original question about my research area, which is about complexity. It's about how hard it is to figure things out, where just a few simple rules can lead to an incredibly complex thing that's very hard to predict. And that's sort of what's happening in computing. It moves very fast, and it's very hard to predict what the ethical challenges are of what you're producing today. And I certainly never thought of, Mark Zuckerberg as someone who said, oh, well, I want to create a system that's going to allow people to manipulate elections. I'm sure that was not his goal or intent or anything he really wanted to do. And it's not like the rest of us were out there saying, your social network can be used in these evil ways. I think none of us realized what was going to happen. And yeah, they had a bit of a freewheeling attitude, but he had a goal of just wanting to connect people and allowing free speech and things that are endemic to our hearts. But when taken to the extremes, and something like Facebook lets you take it to the extremes, it opens up a huge amount of very bad behavior that can be out there. People manipulating people just, machine learning algorithms that shows people what they want to see, so that causes echo chambers and separates us instead of bringing us together, which I think was the original goal of a social network. So it's very, it's thinking sometimes it's easy to say, oh, these companies should have thought better, or they should have had some review board, or some ethics that they should have done. But I think it's just very, very difficult to understand what the outcomes. So we just have to be cognizant as best as we can and try to deal with issues as they come up. But don't underestimate the real difficulty of trying to predict how a technology today can be used in the future.
I mean, yes, a lot cannot be predicted, but aren't there some general principles that are helpful in guiding the development? For example, respect privacy, or informed consent of everybody involved, informed consent of users, lack of discrimination, fairness, principles like that, and they could help if there was a higher awareness of these things. Let's say informed consent. People would know better what would be done with what is being done with their data. They could prevent certain uses of their data, things like that. I mean, this could be some general rules or some general concepts to kind of establish as central. What do you think?
Some people have talked about something called abusability testing for AI, where you think about if you use kind of like IIT is really good at design. There's the Design Institute here, and they do something called foresight thinking. And there's been some proposals that we do a lot more that in AI. So you really think of not just like, oh, this is super useful. And I think back to a few months ago reading the story about the robot that wheeled its way into the guy's room to tell him, guess what, you're dying. Super efficient. An engineer designed this robot to come and say you're dying. It seems really efficient, not the best use of a robot. And had we use some design, some foresight thinking to think, what are the really, really great uses of AI? Computer vision to diagnose illnesses, but what are the really, what's the spectrum of things? I think computer scientists, AI people, machine learning need to partner more with more design people and people who think, it goes beyond your classic kind of UX, like design of an interface. It's really thinking about system designs to think about things like privacy. People don't care about privacy implications. I mean, this is not a battle we fight all the time. Where if you think about what Facebook's doing with your data, by and large, its studies have shown time and again, people want convenience. They don't necessarily care. Should they care? That's a different story, but they don't. But it's kind of more robust interactions, I think, with design could serve us well in computer science.
Now, I'll just say one thing to kind of encounter to what was just said. Facebook is a good example of designing without safety. Namely, they could have asked a media historian, which I'm not. It's certainly not the first time that a new medium has been used for propaganda. Father Coughlin on the radio is not a new thing. Many of us have heard of this guy, even if we never heard him actually. Rwanda had happened on the radio, where people literally killed others because of ethnicity in that. Just nobody bothered to ask. And secondly, it was a good example where it became obvious that these systems had significant risks, safety risks, and the reaction to that was we do the minimum necessary to get the politicians, the journalists of our back, as opposed to designing systems where we can tune back the knobs in that when it turns out that the thing maybe shouldn't be running that fast. Maybe we should limit the spread of information in that when it turns out that the information that spreads leads to really bad outcome, as in people get killed. So I don't blame, it is not one where this was the exact outcome could not be predicted by that. That's true. But if you're operating in a dynamic environment, if you don't design your system for well-known human characteristics, and you don't build in safety mechanism where you can very quickly adjust to that, like we do in other engineered systems, where you have usually a fallback mode in that, you have emergency brakes, you have all kinds of things that you have backup systems that you do. Then, yes, I blame Facebook in particular and other companies like that they didn't design their system of safety in mind, which in other engineering disciplines gets you fired or worse. And in computer science, we seem to tolerate.
But Facebook's very fundamental system runs on privacy violations. I mean, it runs on the fact that, I mean, I guess that word itself is open interpretation, but the very foundation of the system is run on the fact that they are taking data that people don't know they are giving up. And I think that's the difference.
There's several aspects.
Obviously, now very complicated aspects and very controversial topics. I would like to open the discussion to all of you, to all the participants, and let's spend the rest of the time we have on questions you have, comments, whatever.
So you mentioned a car hitting a lady on a bike, which I've never heard about, but after I thought about it, you were saying that the car couldn't recognize the lady because there were some bags on the car, on the bike, which made the bike not look like a bike, perhaps. And so my question after I thought about that was like, well, wasn't a person driving, so what difference does it make what the car thought?
No, this was a self-driving car.
Real?
No driver.
No driver.
On a real street?
On a real street.
Well,
And
that's
not
the
a
point.
simulation? It wasn't a simulation? They weren't testing?
No.
No, they're
So
out there in the
there
streets of
was a
Pittsburgh
safety
and
driver, but the
different
safety
places.
driver was distracted because most of the time, I mean, you designed a system, and again, this has been known since the beginnings of railroads, that if you have a position which 99% of the time that has nothing to do, expecting the person to be fully alert and react on an instant's notice in that 1% when there's a bicyclist is just a design that is fundamentally flawed. And any psychologist would have told Uber that if Uber had asked. This is not new knowledge.
Yeah, I'm really interested in tech, and particularly as an African American male. I'm really, I've been thinking about this whole thing about tech ethics as we move further and further into tech. I mean, if we can't deal with a society that basically has a lot of discriminations and biases and unfairnesses, is it really realistic to expect for tech to handle those situations? I mean, you look at our law. Our law is supposed to deal with that, and it hasn't dealt with it fairly in this society. So what is really the role of tech? What is the expectation of tech? And, what is the realism there? It's just my thought.
First, don't make it worse.
Do no more harm?
I think there's no doubt that we're failing there. I mean, we're failing there on many. We're also don't have a great. You look at this. Look at our panelists here. We don't have a. There's not a lot of great diversity in the tech community itself, and I think we need more of that in order to get the viewpoints from a broader base of people, so we even understand what we're not doing right. Used properly, tech can make great advances because humans tend to be inherently biased, even when they try not to be. So I think tech can help us try to understand the problems, and we can try to frame them and try to help them. Are we going to get perfection? I don't. We'll never get perfection, but I think we can try to help.
Yeah, so what I was going to say is going to be close to a comment on that, which is, I mean, became an engineer decades ago and was always a bit conflicted about it because I felt like somehow engineers were conservative and they had to keep the status quo or something like this. And I was kind of ambivalent for a long time. And in a way, we're talking about the engineers aren't going to solve the problem. Not one element of the society is going to solve the problem. And we all are human and part of the society. So we all are, have failings. And our solutions, we do have to be pulled back from the edge. And we have to modulate what we're doing. So if I'm doing machine learning, for example, I need to be aware that I need to modulate the solutions that the machine is giving me using my social awareness and my humanity and so forth. And we're part of the solution and we're probably part of the problem. But but as long as we don't think that our current state is the final the final answer to the problems, and we don't give up our autonomy or societies to some machine, I think that we struggle onward. So I think that this technology is part of the answer.
I think what we need is an interdisciplinary effort and have a lot of disciplines involved, not just computer science and not just blaming computer science, but the social science, ethics, philosophy, psychology, design, history, politics, all kinds of fields, and stakeholders in the various fields, and have a discussion together and try to solve these things together. I think you are next, and then it's you.
Okay, in 21st century, I think this inflection point is the best thing ever happened to the humanity, to displace it from its comfort zone or / status quo. But the way machine learning is applied, it's got a little biases because it's poor statistical analysis. The data that's harvested, it's got lots of noise. It's very hard to really ascertain the particular data. But one has to come up with specific instrumentation and more precise in order to really cleanse the data to make decisions. When it comes to population displacement, biases and all that, it's an inherent characteristics of human. 75% of global population suffer some form of cognitive dysfunctions / some chronic diseases. We don't see it, it's underneath. It's not visible to naked eye. Our present system, barely 2% efficiency. So cross-disciplinary, I think this is the ideal. Everybody's got stake at it. But I don't see most of the solutions that exist out there right now are not solving actual problem, are contributing to the problem. The essence is to get multiple stakeholders and create some sort of a 360 solution to integrate, to benefit each other, because we live in a dynamical world. Things are becoming obsolete on a weekly basis. So let's not blame each other. Let's come up with a solution. Everybody's part of the solutions, basically. Thank you.
Last question?
Yeah. Hi, thank you. So the point is that like unintentional bias can also be introduced in like algorithmic design, right? Because normally people would say machine learning algorithm would just reflect the data that is given to it. But one example that I got from my favorite podcast, Linear Digression, was that there's a very famous example for machine learning is called analogy task. So basically, a queen minus woman would be equal to a king minus a man. So this is how you do like word to vec, some like embedding task. And what's terrible is that if you do doctor minus man plus woman, you would get nurse back. This is terrible. This is terrible. And initially people would believe, oh, this is just from the learning text, the data. But there's some paper analyzing the actual algorithm. They actually discovered that there's a constraint in their training. So like, for example, A is to D, A is to B as C is to D, right? They are like constraining, like A, B, C, D cannot be the same. So that partially explained why women cannot be doctor, because man is already a doctor. So it's forced to women to be a nurse. That's in the algorithm design. So this is actually very terrible. But I don't believe, the designer, they have such bias in their mind, but it's just algorithmic. Maybe they just trying to do a better optimization task, because basically it's gradient descent. Maybe they're just trying to optimize accuracy. But, this kind of, in optimization, we always have some constraints, and it's algorithmic. It's algorithm, but but it has some physical meaning after the result comes out. So maybe we have to be more vigilant in designing too. We cannot just blame data. This is a comment.
Yeah, so I'll just make one. Again, I want to just emphasize that emphasizing individual responsibilities are good and great. If we look at, and I will disagree that we are actually from under fundamental distinction, that our progress has been so much more radical. I would argue that somebody entering the 20th century had far more radical transformation than we did. We have better advertising technology, which is largely what we've created, as opposed to somebody who can fly when they couldn't as a kid, who could drive long distances, who had penicillin, all the things that I don't have to go through. What we don't have, we had a much better sense after some really dramatic all of those technologies were quite dangerous to begin with. Cars were individually dangerous, trains were, planes were, but there was a notion that constraints would be imposed that would limit the inherent incentives of the operators of these inherently dangerous technologies to do what was just good for their immediate profit maximization. We have lost that. The idea that potentially, and this is why I said dual use technologies, we do that for chemicals. We do that with chlorine. We have decided for some reason that Mr. Zuckerberg can just simply do whatever he wants to, that other companies that make equally dangerous stuff should just be able to do whatever they want to without any external liability, without any external review, and without even a sense that this is something that can be addressed at a larger scale than just the responsibility of individual engineers.
Unfortunately, we have to stop here because our time is over. I would like to thank all of you. I would like to thank the panelists, all of you who contributed to the discussion, all of you who stayed here, and a particular thank I want to express to my students from the Ethics of Information and Communications Technology class who are sitting behind here and who came and stayed during the whole discussion. Okay, thanks everybody.
Basically everything you said. I disagree with you. Good.
able chief technologist explained the APA better than many lawyers I know, and I don't think I could do nearly as good a job of explaining how 5G works. So I'm going to instead just give an overview of some of the things that the Commission, under Chairman Pai's leadership, is doing in the area of next generation emergency communications and public safety. If time permits, and I'm hopeful that time will permit, I'm happy to take some questions at the end. So I want to just start. I work in the Public Safety and Homeland Security Bureau at the FCC, and we actually have a motto. Our mission statement is very simple. It's the public's safety is job one. Kind of corny, but we believe it. We really take it very seriously. We are the Commission's primary experts on public safety and homeland security matters. We develop and implement policies consistent with the FCC's statutory authority to serve this mission. And let me talk a little bit about some of the things that we focus on. Some of you already know this, but for those of you who don't, what particular activities does the Commission engage in with respect to public safety? Well, some of the things that we are working on, have been working on for a number of years and continue to. Number one, 911, helping ensure that anybody who needs to call 911 can do so and be located by first responders. Another area is emergency alerting. We regulate the provision of emergency alerts by commercial providers. We don't originate alerts, but when those alerts come to you over your television, your radio, your cell phone, we regulate those providers in the way in which they deliver alerts to you. So another part of our mission is to strengthen that alerting system and provide better tools for the emergency managers that use it. Another function is simply promoting the resiliency and reliability of communications networks, whether they're used by public safety or by the public. We deal with trying to make those networks more robust as technology changes, as threats to technology evolve. We deal a lot with physical threats to networks from wildfires, hurricanes, floods, and the like. But we also deal with threats to the technology that could come from a cyber attack or from simply mismanagement of the network, often just what we call sunny day outages that can be caused by something as simple as a company decides to do a maintenance upgrade on a piece of software in a system, and lo and behold, when they do it, the whole system goes down. So those kinds of issues recurrently come up. And then finally, both preparing for and responding to disasters to promote continuity of communications. Our work includes regulatory action. If you were at Eric's presentation, you saw that chart where he described the legal framework, the administrative process, the appeals process. I work in that space, that green APA area that he described. That's where I spend most of my day. But we use a lot of other tools as well, because we have to work collaboratively with a lot of stakeholders. There are certain entities that we regulate. We regulate commercial carriers, cell phone companies, broadcasters, and the like. But we also work with a lot of organizations, including the local 911 call centers, which we do not regulate, but we work with them to try to develop our policies. And we work with technology innovators. And I will underscore and echo what Eric said, which is input from the technology community in our processes is incredibly valuable, incredibly important. I've worked with some of the best technologists in the business. Some of them, Henning and Eric, are here in the room, and I've been delighted to be associated with them. And their input when they are at the Commission has been incredibly valuable. And the input of technology experts outside the Commission also really helps us to come to the right decisions. So I'm going to just highlight a few things, areas that the Commission has worked in the past year to improve public safety. I'm going to start with Kerry's Law and Ray Baum's Act. Eric talked a little bit about that earlier today. So let me just give you an overview of where we are with that. In August, the Commission adopted a sweeping order that implements these two new federal laws that improve key elements of the 911 system. The first is Kerry's Law, and as most of you know, but if you don't, Kerry's Law was enacted in response to a really quite simple technical problem that had an incredibly tragic outcome. Carrie Hunt was a woman in Texas who was attacked and killed in her hotel room in 2013. Her young daughter was in the room at the time. She tried to call 911 from the room repeatedly, and she couldn't get through because she did not know that in that hotel at that time, you had to dial 9 to get any kind of outside line, even if you were dialing 911. So that tragedy led to Carrie's father, Hank Hunt, making it a personal mission to change the law and to change the practice with these types of systems. He worked with Chairman Pai, he worked with Mark Fletcher, and with a lot of others, but almost Herculean efforts to change the law and change the practice, and to pass a law that would require multi-line telephone systems, what we call MLTS, to support 911 direct dialing, to simply take that prefix off the number so that if you dial 911, you will get to 911. A number of states, before the federal law was passed their own laws with such requirements. And then in February of 2018, Congress passed the federal version of Kerry's Law, and that became part of the Communications Act, which is the Commission's governing statute. So that then became a law that the Commission is empowered to implement and enforce. And that version of Kerry's Law, the federal version, requires all multi-line telephone systems that are manufactured, sold, or installed in the U.S. after February 2020 to support 911 direct dialing. The law also requires these systems to provide an internal notification when a 911 call is made, such as to a front desk or to a security office, to facilitate the building entry by first responders. And it's important to underscore that when we talk about multi-line telephone systems, we are also talking about IP-based and cloud-based systems that functionally do the same thing as a traditional multi-line telephone system. So this is not just a law that regulates old-fashioned circuit switch telephones. So in August, the Commission adopted rules that implement Kerry's Law, and between now and the February 2020 implementation date, when the requirements go into effect, we are encouraging all entities that are affected by the law, governed by the law, manufacturers, installers, and operators of these systems, to, number one, understand what the legal obligations are under the law, and to make sure their systems have those required 911 capabilities. And the good news is the technology to do this is already out there. It's widely available in the marketplace, so compliance is not difficult or costly. Now, the second law that was enacted about a month after Kerry's Law was Ray-Baum's Act. That was enacted in March of 2018, and a particular section of that act, Section 506, called on the Commission to look broadly at improving 911 location for all communications platforms. And specifically, the law directed us to look at the feasibility of having what we call dispatchable location conveyed to a 911 center with each 911 call. And dispatchable location, it's a term of art in the public safety community. It is what first responders refer to as the gold standard for having knowledge ahead of time of where somebody is that they need to reach in response to a 911 call. Typical example, if someone is calling 911 from a building, let's say a multi-story building, from an apartment, from an office in that building, dispatchable location means you not only know the building, you know the floor, you know the apartment or the office number, so you know the precise location of the caller inside that building. And in August, as part of the same order, Congress adopted dispatchable location rules for a number of different platforms, for multi-line telephone systems, for fixed telephone service, which already effectively provides dispatchable location, but nonetheless, we included them in the rules because we wanted it to be comprehensive. Interconnected voice over IP, and telecommunications relay services and mobile texting services. And those platforms combined probably account for about 60 million 911 calls a year nationally. So what the rules require is that if a 911 call is made from a fixed device from one of those platforms, the rules require automatic delivery of dispatchable location to the call center that the call is sent to. For those that come from mobile or nomadic devices, and of course these devices are increasingly mobile and nomadic, the rules require delivery of automatic dispatchable location if it is technically feasible. But if it's not, then service providers still have to provide alternative location information, such as a coordinate-based location, that identifies the caller's approximate location. And we made the rules flexible. We provided alternatives because we wanted to be sure that even if first responders didn't know the exact dispatchable location of a person in a building, knowing the approximate location of that caller, such as what floor they're on, such as what quadrant of a building they are in, that can save minutes in getting to that person. And minutes matter when you're talking about first response, particularly in medical emergencies, but really in all emergencies. The faster first responders can get there, even if it's a matter of seconds or minutes faster, the better off everyone is. So those requirements are going to take effect in a year for the fixed services, 2 years for mobile and nomadic services, once the rules become effective, and they should be effective quite soon. We have to publish them in the Federal Register before they formally become effective, but that process is underway. And we took the approach that we've generally taken with respect to location requirements, which is the rules are both technology-driven but also technology-neutral. They're technology-driven in the sense that as part of the rulemaking process, and this is why getting contributions from the technology community is so important, we need to know what is possible, what is actually already being done or what's being worked on in the technology world, so that we can have a general understanding of what is technology capable of doing now and in the future. So we have an understanding of how much these technological changes might cost to implement. So that's important information to have. But we also, as a matter of policy, make our rules technology neutral in the sense that what we do is we say, okay, based on where we think technology is and it's going to be, here's what we think is a reasonable target, a functional requirement for 911 location. That's the target, that's the goal. And you can use any technology or combinations you want to achieve that goal. We're not going to tell you which technology is the right one to choose. That's really something that the technology community is much more expert on than we are. So as a result of these regulations, what we hope to see, and I think we are seeing, is a lot of companies that are already trying to solve these problems, but we would like a broader community of innovators to look at how do we come up with common technological approaches to location when we're talking about environments like office buildings, apartments, campuses, shopping and entertainment complexes, transportation hubs. So that is one piece of our 911 portfolio where we've taken significant action recently. And then we also have for a long time focused on location accuracy for wireless, for cell phones. That represents probably 75 to 80% of the 911 calls that are made nationwide every year. It's about 180 million wireless 911 calls a year. We've had location accuracy rules on the books for a couple of decades, since cell phones first became ubiquitous and people started using them to call 911. But we updated those rules in 2015 in order to address the issue of wireless calls, particularly from indoor locations, because as people cut the cord and as cell phones and smartphones become more ubiquitous, more and more calls were coming from indoor locations where the technologies that have been implemented in the first generation of cell phones, like GPS, would not work to locate the caller. So we have rules already that require wireless carriers to meet an increasingly stringent series of location accuracy benchmarks that apply to both indoor and outdoor calls. Like the rules that we just adopted for Ray-Bombs Act, our wireless rules also provide for dispatchable location. So they encourage the provision of location by dispatchable location. But we also allow and have benchmarks for coordinate-based location, provided it meets our accuracy benchmarks. That is sufficient for carriers to comply with the rules if dispatchable location isn't possible. And these are horizontal accuracy requirements for now. And the degree of difficulty, the sort of the height of the goalposts for the carriers is increasing over time. We have benchmarks coming up in 2020 and 2021 that are going to require carriers to deliver horizontal accuracy within 50 meters for 70% and then 80% of all wireless calls. The other piece of this is one we're working on now. Last March, the Commission issued what we call a further notice of proposed rulemaking. In Eric's chart where they talked about rulemaking, sometimes when we do a rulemaking, we adopt an order. We also say, well, maybe we should ask some more questions about what the next phase is going to be. And that's what the further NPRM was. And this was to tackle an issue that we had left open in 2015, in the 2015 order. And this is, how do you establish an accuracy metric for a wireless call in a multi-story building where you not only want to know their XY, their horizontal location, you want to know what we call the Z-axis, what floor are they on? Because vertical location information, again, by helping to identify the floor where the call occurred, that can reduce emergency response times and save lives. After 2015, we told the carriers to start testing vertical accuracy solutions. And in fact, the industry created a test bed, which showed the potential of using a particular technology based on barometric pressure sensors, which are a standard component now of most smartphones to provide vertical location. But we also note and are interested in other technologies that may support vertical location. So in the further notice, this is back in March, the Commission proposed that wireless providers meet a vertical location accuracy metric. And the metric that we proposed is plus or minus 3 meters relative to the handset. So if you make a wireless call, 911 call with a handset, the information that's provided through the handset and the network should provide the vertical accuracy within plus or minus 3 meters, which is it's sufficient in some, maybe not all cases, to deliver floor level accuracy. But it will at least, if you're in a multi-story building, a plus or minus 3 meter standard will eliminate a lot of floors where first responders don't need to look. So that was the proposal. We received a lot of comments on this proposal, that comment process that we talked about. And of course, I'd love to tell you what the Commission is going to do, but I can't. I can assure you we're working hard on it. We're working hard on it right now. When I go back to the office tomorrow, this is what I'm going to be working on. So stay tuned. There will be more on this, and I hope soon. Even as we're deciding what accuracy standards to adopt in our rules, though, my message to the technology community would be don't just look at what the FCC rules require. The two important things to remember about our rules: first, they set a floor on what is required. They do not set a ceiling on what is possible or what we would like to see. And second, they're technology neutral, which means we're leaving it wide open for innovators to improve on the performance that we require as a baseline, and to explore new and novel approaches that can go, again, across platforms. I like to think of, when we're talking about indoor location, coming up with solutions that can work regardless of the kind of device that the person uses to call 911. If I'm in my office and I need to call 911, I could use my cell phone, I could use my desk phone. They go on different networks. They are transported to 911. Hopefully they go to the same 911 center. But very different things happen right now depending on which device I use. And ideally, it shouldn't matter. Whatever tools are available to provide more precise location should be in play and activated, whether you're making a cell call or a call from your desk phone. Either way, it's the same problem that needs to be solved. And there are no constraints on the imagination of technology innovators to try to solve that. Historically, they've always delivered. I think they can do it again. And that will help us. It will also help the 911 community and the public. So let me switch gears just quickly and talk about a couple of other areas. One is wireless emergency alerts. This is kind of the flip side of 911. This is not how the public calls for help. This is how do emergency managers, emergency agencies inform the public about dangers and perhaps how to avoid or respond to those dangers. So we have two systems. Wireless emergency alerts, those are the emergency alerts that are delivered on cell phones and other mobile devices. The WIA program has been in place since 2012. It's proven to be a lifesaver in a lot of cases. It warns people about imminent dangers like tornadoes, flash floods, wildfires. It's also used for things like amber and silver alerts, so it alerts the public to help in finding a child or a senior citizen that's missing. And the technology, even since 2012, has enabled us to take a series of actions to improve the delivery and the content of those WIA alerts. So just a couple of examples. Wireless providers must now support clickable links in WIA alerts, which means in addition to just getting a text message, you get a URL that you can click on that may provide additional information. We're also expanding the length of the number of characters that can be included in a wireless emergency alert. The original system was subject to a 90-character limit, so it's a pretty short text message. That's being increased to 360 characters. And we'll also support messages in multiple languages. We'll also support wireless emergency alert testing and the ability to provide messages that convey recommended actions to the public. So not just a tornado is coming, take shelter, but maybe information about where shelters are. These improvements will become available when FEMA, which also has a role in this through its IPAWS system, which is the gateway system through which alerts are sent, is ready to support all of these improvements. So we're all waiting anxiously for FEMA to declare that that capacity is implemented in IPAWS. Another area that we're working on, and again, where technology has significantly improved performance, is geographic targeting of alerts. Emergency managers, they always emphasize to us that wireless emergency alerts need to be very carefully targeted. So they reach the people at risk in affected areas, somebody in the path of a tornado, but they don't go to the public in places that are outside that area of risk, because if you don't have precise geo-targeting, what you tend to see is alert fatigue. People start ignoring the alerts, and that can reduce their confidence in the alerts and the trust in the warnings. So since WIA was first launched, we have seen improvements in technology that support geo-targeting, and we're requiring wireless carriers over time to implement those advances and increase the precision of the geo-targeting of the alerts they send. So originally in 2012, our rules said that you had to geo-target alerts at the county level, but you didn't have to require targeting within a county. There are a lot of counties out there that are big. I come from Los Angeles. Los Angeles is a big county. So targeting an alert to all of LA County is going to get you about 10 million people, which is probably not the audience you're looking for. In 2017, we tightened the rules to require wireless providers to transmit to a geographic area that best approximates the area of the emergency. But we didn't in any way constrain if there was an overshoot. We didn't constrain that. But now we're tightening the rules further, and beginning at the end of November, wireless providers will have to provide wireless emergency alerts in the area that the alert originator specifies. So the alert originator says this is where the alert needs to go. And the alert needs to be targeted to that area with no more than 1/10 of a mile overshoot. So that's going to be much more precise. We think this is going to make alerts more effective in targeting, not only those that need to receive them, but also it will help to reduce alert fatigue, because people who don't need to see them won't. But again, we're very open. If technology pushes the envelope further, that's great. If we can do even more precise geo-targeting, then that's a good thing. So this is another area where we would encourage technology not just to do what the FCC rule requires, but to see whether you can exceed that. We're also, let me talk finally about 911 resiliency and reliability, because this is another priority of the Bureau in promoting resiliency and reliability of communications networks. we're concerned about communications networks. Generally, we're particularly concerned about 911, that 911 always needs to be there for the public. But there are also outages, and when those outages occur, such as during disasters, we work with government partners at the state and local level, at the federal level, and with industry and to support service restoration. And then after the disaster, we investigate so that we can apply the lessons that we've learned to improve future preparation and response. Just a couple of examples that I'll give before closing. Earlier this year, Lisa Folks, who is our bureau chief, my boss, she traveled to Northern California to meet with public safety officials in Northern California, from whom she learned firsthand about the threats to communications posed by wildfires. Well, this has been in the news. California energy providers are now implementing planned power outages as a fire prevention measure in areas where the wildfire risk is high. Anticipating that, Lisa sent letters to the nation's largest wireless providers saying, you need to tell us what steps you're taking to keep wireless service available in the event of one of these power shutdowns. And we got responses from all the carriers, and they are all public, and you can read them. We're also reaching out to California public safety entities, communications providers, and power companies to see how we can help improve coordination in the future. Our goal, I don't think we're there yet, but our goal is to ensure that communications networks stay on when the power is shut off. There's a lot of progress that's been made in that area, but there's always more that can be done. And the other example illustrates this. A year ago, Hurricane Michael inflicted enormous damage on a lot of communities in the southeastern United States, particularly in the Florida Panhandle. And a lot of things worked right. 911 responded pretty well. Where there were 911 failures, calls could be transferred from one PSAP to another. So it underscored some of the lessons we've been trying to inculcate, that redundancy, route diversity are really important for the resilience of 911 service. But not everything worked the way it should. And so, although wireless service in most areas affected by Michael was restored fairly quickly, within a few days, the recovery was a lot slower in a couple of counties in Florida. The Bureau investigated that. We released a report in May. Again, you can find it on our website. And it found that there were three factors that led to the slower, the really unacceptably slow restoration of wireless service in those areas. The factors were lack of resilient backhaul connectivity, inadequate roaming arrangements. Roaming was supposed to happen, but the arrangements hadn't been made to activate it. And also lack of coordination between wireless service providers, power crews, and municipalities in the restoration effort. So one of the things that happened several times was that backhaul was not destroyed by the storm, but it was impaired by repair efforts after the storm, because somebody would come in with a backhoe to clear trees and debris, and in the process they cut the cable, the fiber that provided the backhaul. We did find in our report that some providers had not lived up in practice to the principles of a voluntary agreement that they had entered into in 2016. As Eric mentioned earlier, often we look for ways for industry to do make voluntary commitments to improve service, and those work in some instances. But we found in this case that some of the principles of the framework had not been lived up to. So we're re-examining that framework. We want to ensure that wireless providers are meeting community needs and doing everything they can to restore service after a natural disaster, and also to prepare for it more effectively to shorten those periods when power and when service is down. So again, this is an ongoing process. I can't tell you where it will lead us, but each time we go through a disaster, and I don't think we're going to run out of disasters, we try to apply the lessons learned and figure out what is the best course to take next. And underlying all of this is technology, which is changing. I came to the commission in 1992, which, as far as my kids are concerned, might as well have been dinosaurs roaming around. And from a technology point of view, an enormous amount has happened. And the technology changes we've seen, they've got the potential to yield a lot of benefits for public safety, but they also present challenges. And so that's why we need input from technology experts as well as others, so that we can be sure that we're taking advantage of every opportunity technology gives us, but that we're also developing rules that will ensure, or at least move in the direction of using it effectively, and particularly in areas like access to 911, location accuracy, and emergency alerting. So that's what we are working on. We're looking forward to working with you to save lives and build safer communities. And that is all I have to say other than thank you. And I don't know if we have time for questions, but if we do, I'm happy to answer questions. Thank you. Do we have time? Are we? I don't know how we're doing on. Well, I don't see anybody. Well, that's very kind, but okay, I'll stick around after class. How's that? Okay, thank you very much. Yes. Are you next?
I'm next.
You're next. Oh, I'm sorry. Did I eat in? I ate into your time. My apologies.
That is A-okay. But I just need to. Yeah, just hey, it's Jay. Yeah, whatever. I do want to make sure this is up. Hold on.
Actually, why don't we go back so we're not interrupted?
You know if this is on? Yeah, the monitor's on. I got it. Thank you.
Okay.
Next up, we have Jay Mallon from Agent 511. Agent 511 is a company that provides the text with 911 services up in Canada. Text and 911 works a little bit different up there. So his company provides that back-end infrastructure as well as the software components that deal with sending and receiving real-time text as opposed to Bodo. Jay, welcome. Thank you.
Thank you. I appreciate it, and appreciate everybody being here. Thank you, and kudos to you for a lot of the work you did on Kerry's Law and the advocacy there that resulted in a very successful outcome from a legislative standpoint. So, thank you to you. Thank you, everybody, for sticking around. I know I'm kind of the pathway to drinks and whatever's next for you this evening, but I wanted to talk a little bit about a subject that was in part an afterthought to the deployment of text to 911. I'll give you a little bit of background on it. It's an active activity that we've been involved with. There was a Google Tech Fest just a few months ago, part of a DHS contract with IGES to deliver text-related translation standards. So what I'll do is give you a little bit of background. We'll talk about some of the standards, some of the proposed solutions, as well as some improvements that we identified, as well as kind of how natural language processing and AI fit in the public safety community. So really what our effort came out as a result of kind of a gap in the text to 911 standards as well as industry efforts. So text to 911 is now universally deployed across the country. I don't know the number of PSAPs. You could actually look on the FCC registry to see the number that are deploying text to 911. In California, nearly half, if not more, of the PSAPs have delivered text to 911 to their citizens. But if you look at the numbers, approximately 20% of the U.S. population natively speaks another language other than English. Some may speak English but prefer to communicate in their native language. And certainly we're familiar with all the capabilities for voice to 911, language line, voyance, other related voice-related translation services. But what it left is a gap as a result of the 2012 notice proposed rulemaking by the wireless carriers and the FCC, NENA and APCO, that led to text to 911, which was ultimately deployed in May of 2014. We started working with one of our customers, Greater Harris County, which is in Houston, Texas. They were, at that point, receiving text messages via 911 in a platform that we put in place integrated with the wireless carrier text control centers, or TCCs, and they identified a number of messages were coming in Spanish. As a result, they requested from us language translation. In fact, there was a fairly high-profile text session that came in of domestic violence. It was in Spanish. The text taker, really had a difficult time in managing, and ultimately reached out to somebody else to help with the translation. But they identified, hey, we need this capability. We looked at related services and determined that machine-to-machine translation was the only capability available at that time. We added an integration with Google Language or Google Translate, and we started in early 2015 providing text language translation, both English and, in Spanish, so that a text taker could identify the incoming messaging session, which I'll show you a little demo, and then they were able to start that translation, which provided side-by-side translation both for inbound as well as outbound messages. Kind of how we got here. As I mentioned in notice proposed rulemaking in 2012, leading to 2014 deployments by all the major wireless carriers for text to 911. But the overriding kind of industry standard for text to 911 was called ADISH standard J110. It does not really address text conversations not in English. If you look across the web or at some of the websites seen in ABCO, they talk about some of the limitations. One is multimedia, the other is language translation. So there really was also no well-established business model. There have been early efforts by LanguageLine and others to try to come up with a universal way to do language translation for text-based conversations. Talking to the wireless carriers and especially the text control centers, they really prioritized a number of other features, including next-gen, over language translation. So as a result, DHS and IGIS, which is Industry Institute, they were looking at solutions and proposed to the TCCs as well as the industry, hey, let's come up with a way to do it. And that's how we got involved in the effort and came up with a couple of different ways and added some of our insights into the, into the mix. But when I talk about text to 911, I'm not explicitly referring only to SMS, although that has been the experience. This could apply to, as Mark Aureli mentioned before, real-time text, other forms of text communication, social communication that ultimately the PSAPs want to receive. So just kind of looking at how we ultimately did it was essentially when a text conversation came in another language, and you can't see the initial message here, the call taker or dispatcher is able to adjust or apply the language assist on the chat window. It does an automatic detection on the initial message. It determines that it wants to do a translation from Spanish to English, and thereafter, any message, these are of course outbound messages from the call taker to the wireless user, how can I help you? They're translated side by side. All that is stored from an audit perspective, and then we send the message back to the wireless user in those languages, and I'll show that as a demo. And then the individual is able to respond in their native language, in this case Spanish, and we then translate the message for the wireless user. And again, all this is still, again, best effort, machine-to-machine translation. We identify for the wireless user. We call this an assistant, not a formal translation like you would with LanguageLine. We also identified another kind of opportunity here. I think it's actually cutting off the left-hand side of the slide, so I'm sorry. But another kind of capability, which was what I call multilingual triage. And we deployed this for one of the major PSAPs where essentially they said, hey, we're not ready to do machine-to-machine language translation, but we at least want the capability, if we've identified messages come in another language, that whether it's our Spanish language call takers or even an English language call taker, could start using a toggle capability to ask questions in a language. So where's your emergency? If they were to toggle to SP or Spanish, they could send that message out in a foreign language. So provided at least some triage capability for the wireless user to be able to communicate in their native language, and somebody within the PSAP to be able to at least use some quick capabilities to acquire information. Perhaps the only thing they could actually ascertain from the incoming message is that they want location, and that may be just one of the questions they ask, but they have the ability to do it without formal language translation. So at the Google Tech Fest, what we did is we demonstrated the ability to do a language translation via language line. In this case, what we actually did is we set up a text conference call. So within our application, we set up a conference call to language line. There is a parallel voice conference call, which is important because essentially what you want to do is be able to have the dispatcher, the call taker, communicating directly with a language specialist. So what you essentially have going is a text conference call where they put in a conference code, be able to transfer it to language line. Somebody within language line is be able to send outbound messages or inbound messages, or at least review the conversation, provide the responses via that parallel voice call. Very similar to what's been done in other environments where they may have calls coming into 911 neutral or to police, and they're able to transfer it to a perhaps specialist in language within the PSAP itself, especially for large PSAPs, New York, Chicago, where they have very large, maybe Spanish-speaking populations or other populations. Similarly, they could have a specialist on duty who's able to then provide those level of responses. So that's how they've been able to do it, is using a conferencing capability. So what I was going to do is just do a quick demo of the web translation tool. And then, what I really want to do is provide you some feedback that we've seen in terms of how well the language translations work and perhaps an area of improvement. So what I'm going to do is open up the app right here. Again, this is our web portal-based app. And my phone is over there. It's a Verizon phone, and I have this Verizon app already queued up, which is a Verizon messenger. And I'm going to send a message here, mi coche fui robado, my car was stolen. I'm going to send it in a foreign language. And what it will do, hopefully, all things go well. And I should admit, last year, my demo was an abysmal failure. But hopefully it'll come in okay. It'll send an auto reply message back to the wireless user. It's taking a second, maybe my phone. Okay, it's been received. And you can see the text came in, and there was a browser notification as well, but I think I was covering it. And I've opened it up now. I'm kind of playing call taker dispatcher. And you can see the message came in. The location here is simply a fixed location. Obviously, I didn't dial 911, so for privacy purposes, we've come up with a fictitious location. I could turn on the language assist here, and what it will do is it will attempt to do a language detection. So what it's done is it's translated my message, and now if I want to send a message out, what is the make, model, color, and license plates. I could send that message out. It will do the machine translation as well. You see that it's translated it, and now I could go back to my app, and what it's done is it's actually provided here, and again, it's not well centered, but it's essentially provided the parallel English and Spanish, and then I could reply back, and hopefully we'll show that we'll come back to the call taker and provide it in that translation. So this is the kind of automated translation capability that's been used in a number of PSAPs that are using our web application. But moreover, really this kind of leads ultimately by transferring to language line, if you wanted to get that live translation, either as a verification capability or in lieu of automated translation, what you could get to. So the next question is, from an accuracy perspective, kind of what do we see? There's an independent analysis. It's actually been written up by George Rice and Red Flash. We collected about 5,000 messages, approximately 200 text calls over several years that we collected in our cloud environment. What was determined by Language Line, they actually did an accuracy analysis looking at not the accuracy of the language translation itself, but the quality of the translation, what it meant from a dispatchable perspective. Better than 50% accuracy, meaning based upon the context and what was in the message itself, there was enough information to dispatch or provide an immediate or real response. Now, the question is, why is it only 50%? We know that Google Translate and others are fairly accurate. And really a lot of it is attributed to the quality of inputs, the use of synonyms. So there are multiple words that may be treated as synonyms. Special characters are always not handled based upon handset, upon carrier, upon tower. So there are a number of factors that go into message coming in and not having the appropriate information. You know, throw in there acronyms and other inaccuracies, and you result in something that's less than accurate. But that being said, a number of agencies have said that something is better than nothing, and having at least some additional information they could use for context purposes is better. So we see that the PSAP community is accepting even machine translated solutions that are considered best effort. But what it really led us to say is, hey, how could we continue to improve this process? And I think the answer lies somewhere in the use of artificial intelligence, and what I'm talking about is natural language processing. So in this case, I received that text message in the native language. I apply, natural language processing and artificial intelligence to essentially determine what is the intent. Is there, anything that could be better gleaned from that before I put it through the translation engine? So, as an example here, and if you look at natural language processing in an intense dictionary, you have the who, the what, the where. So this is my father, had a heart attack, but in Spanish, properly translated, and essentially, we've then done the translation once you've ascertained the necessary components, both from a public safety perspective as well as just using AI on the native language to result in improvements. So, this is where we see maybe that next level of DHS study, or others that may want to study how to use natural language processing and AI to ultimately not only improve the routability of a conversation, but to get to that point where you see better language translation. Shifting gears just a little bit, kind of brought us to another point, which is, yes, it's nice, we have this web-based application, we have some customers out there, but it leaves a much larger part of the market space that doesn't have any language translation capability. And there are a number of PSAPs around the country. I won't say they haven't done text because there's no language translation, but have been very hesitant to do text without language translation capability. And if you look at a number of the public safety agencies, they have solutions from providers that you're very well familiar with, whether it's Viper or Vesta, Intrado, or now part of Motorola, that do not have native language translation capabilities, and a number of other vendors. So really, we looked at and said, how could we come up with a solution that is completely independent of whatever communications gear exists within the PSAP? And we came across a capability that has been, fairly well used in the text to 911 space, and that is transfer. And on some of the TCCs, there's an ability to transfer a text call. It does come with its challenges, but ability to transfer a text call to another agency. So what we decided to do is, working with one of the TCCs, namely Intrado, came up with a capability so that PSAP could essentially use that transfer capability and not really transfer the conversation because it became more of a conference call, but include another 911 center. So essentially what you have is you have the original 911 center that received this message maybe in Spanish or another language and said, hey, I need a language translation assist. And what they did is they transferred or conferenced in another site, namely an automated language translation PSAP. So what we did is we built a language translation solution that was connected to the TCC that allowed for that conference calling as if they were talking a language line, but instead they're using an automated version. And what we did is side-by-side messaging. So as an example, somebody texts in, there's a message that comes in, and they receive various messages, some of which are actually live messages from the PSAP itself, and others that are part of that automated language translation. So architecturally, not to show you an eye chart at this time of day, but essentially you have the text control center that's connected to us, and essentially you have a PSAP that wants to get a language translation. What they do is they would invoke that transfer capability from their PSAP. It comes into the automated language translation solution, and using both private messaging as well as just standard language translation, does that automated language translation, and is able to send them back to that initial PSAP. What it does is it serves as machine language translation capability connected to a 911 center who may not have the existing CPE or equipment that's capable of doing that. I have a little video here. It's not easy to do that demo, so I'm going to just show the video. And it moves quickly, so I'm going to try to stop it as best as I can while it's going. So let me blow it up too. It'll make it easier for everybody. Let's see if this, oops, let me get rid of this. Oops, it's still going. So on the left-hand side, let me just stop it. So on the left-hand side here is actually, it's just a Google-connected phone, but it's a phone that's able to send messages into the 911 center. So this is the citizen or wireless user experience, and then this is the experience for the call taker and the PSAP. And essentially, they've received an incoming text call. The PSAP opens the text call, and you see them in the same chat window that I was using before, and they've now received the message. They can send out a message, which is essentially to add the PSAP. So here what's happened is they've sent an in-band comment, or they could do like refer to transfer to another agency, and they send a translation request to the TCC. And what that does is it invokes a conference call with the additional machine translation PSAP. And I'll keep going. So what's happened here is a dialogue was transferred to the translation PSAP. You can see that system message here. That's actually generated by the TCC or the Text Control Center. And then you see a series of conversations, which is basically the automated language translation PSAP starting to translate messages. So the individual wrote in, I have an accident with their car. It's getting translated, and you'll start seeing the conversation going through that continuous translation. The individual sends out a message. And let's see if I can find that here. Stand by for assistance. And what's happening is really the individual on the right-hand side is texting with the individual on the left-hand side. This individual is texting in Spanish. That's the call taker. And in the background, this automated language translation is doing the automated translations. So you can see here that the translation, is actually occurring in real time, but it's being done in the background. If you notice, we didn't turn on the language translation engine at all. It's actually being done as part of the conference bridge with the PSAP, which just kind of leads us to the broader capability where you're connected to a service, like the TCC or a selective router. Can you take advantage of some of the capabilities that exist for conference calls and transfers for the purpose of language translation, for the purpose of artificial intelligence, multimedia, and other types of routing where the native call handling application does not support it. So this is just a kind of quick sampling at this last minute of how you could provide services for those who are not native speakers of English, and deliver something broader to the community. And all this brings me just to kind of this use of natural language processing and AI. One example here, what we did is we started collecting multimedia pictures from wireless users. We've been doing it in Chicago for a number of years in partnership with the OEMC, but this is just a sample where we ran it through a simple AI engine. We determined some of the intent of the call. So if you run this through even something simple like the Google AI engine, a picture, you could determine, hey, what's the probability of the content? And if you look at that AI, that API, there's actually a number of other things that come to bear. Is there nudity, adult content, violence, profanity, etc., related to that picture? That allows you to say, hey, we should circumvent sending this to a call taker or dispatcher and send it directly to a surveillance group or a detective. So there's a lot of cool kind of new capabilities that are leverageable even out of band from a 911 call. And this is actually a demo that we did at NINA this year. We're using location capabilities as well as AI to kind of help reroute calls. So a call comes into the PSAP, you determine, hey, there's a particular accident and we want to send all the calls to a supervisor or a particular group, you could do that. And the same thing with even keywords. So keyword, accident, or keyword, I don't even want to, use them this day and age, but the kinds of tragedies that occur, you can start collecting all those within a certain group of individuals that are starting to manage those conversations. Provide a real-time response like, hey, we're aware of the incident in your area, your call is being routed appropriately. So just some new things that we're starting to see in the areas of natural language processing, AI, whether it's embedded in a web app or integrated and connected to the text control center, some new things that are coming. So just kind of giving a quick summary, trying to fit everything in the time. We've seen a number of PSAPs that have said, hey, in order to deploy text to 911, we need translation capability. The overriding language has been Spanish. We, like some others, have been working to qualify some of the other languages, and you see them around the country, common themes, whether it's Korean, Mandarin, Chinese, Arabic, and then you find communities that have large Hmong populations. So there's kind of a wide array of languages that are being requested from translation perspective outside of just Spanish. The difficulty with live language translation continues to be the business model. There's still only a handful of text messages coming into the text control centers and the PSAPs, and as a result, the traditional business models for language line and other live language translation solutions do not exist. Maybe in the future, but in the meantime, automated translation is really kind of where it's at least from this time. It's a mature technology in terms of translation, but applied to public safety and then using AI or natural language processing to continue to tighten it up seems to be one of the initiatives. And we see activities through the IAB and IGIS, as well as DHS, to continue looking at solutions that will evolve language translation. So with that, I appreciate everybody's time this afternoon. My email address is there, or if you have any questions or comments about this, feel free to let me know. I don't know if we have any more time. I think we're kind of at the end for questions, but I'm happy to take them or not take them. So. Or if you want to ask David any questions, I'll but maybe he's done. Maybe he's like ready. I need a drink before I could talk. So, adding that.
Yeah, so a quick question. Based on what you looked at, what are the predominant text mode emergencies? Now we have enough data, when everybody talked about domestic abuse as being one classical use case.
Yeah. So, without being quantitative, because I actually don't have the quantitative breakdown. The qualitative breakdown is anything that's considered non-emergency, even if there's a text for it. Generally speaking, public safety will not use text to respond. They will generally refuse it and ask you to either text 311 or dial non-emergency services. So that has not been a driver. I think what you said and what we've continued to see and others have seen, if you even look in the media in terms of another text to 911 save, has been domestic abuse. And as I mentioned before, that was a driver for even the Spanish language translation. Was a spouse sitting next, or a partner that was sitting next to engaged in some kind of domestic abuse or violence. They texted in, and but they did it in a foreign language, and that's really been the driver. So I think your proposition is that's correct. I have not heard or seen of the folks in the trunk. Remember somebody's driving around, they're locked in the trunk, and they can only get a text off, and they can't get a voice call. That we have not seen. I've seen strange things. So during Hurricane Harvey, where our application was deployed in Houston, noise complaints for parties in the middle of a hurricane seemed to be, and those did not really get answered or were immediately given like a canned message, try back later. I really do think you're right. It's been domestic violence. Crime tips. I saw one where somebody, their store had been vandalized. They were looking for support from public safety, but I think overwhelmingly that has been the critical violence situation beyond all the other kind of more trivial noise complaints during hurricanes. Party is really loud. Sometimes you get somebody that has additional evidence or information. They felt this was a more anonymous way to do it, but I think that's right on that. That's been the driver from in helping to solve violent crime. You had a question back there. Yeah, so they're publicly available translation APIs. We use Google Translate and Google Detect, so those are the APIs we've used. And as I mentioned, even for the AI API, if you go and I mean, there's no mystery. Google does offer even an AI picture service. You could use that as well. I didn't hear you. That's not translation. That's using natural language processing, and machine learning to ultimately drive towards better language translation. Pardon? So we've started using an intense dictionary. So we've actually built our own model and own dictionary to help drive that process and use that. One early example that we're doing is in the city of Chicago for non-emergency services is using that engine to acquire information for service requests and then drive those service requests to non-emergency or 311. So, yeah. Any other? I think we're up on time, so I'm going to stop now. But I appreciate everybody's time today. I'll be outside, as I'm sure others will be, to ask any questions. So thank you. I appreciate it.
Okay, our next speaker and last one for the day, right before drinks, is Bill Pullmans. Bill is new to the conference this year and brings in a bit of a modality that we don't normally consider part of communications, and that's ham two-way radio. But in the event of an emergency, it's typically and quite often one of the last modalities that's working. Matter of fact, at dinner last night, he told me that no data, very little data, came in from Puerto Rico during the last hurricane because there were no ham operators on the island that were transmitting. Bahamas. Thank you for correcting that. So with that, this is an interesting additional modality I think that we need to pay attention to. And I'm actually very interested in how two-way radio and ham operators can add to the context that we have.
I don't know if that's a capital C or if that's a...
So while she's having trouble logging in to the computer, so I have a couple of questions to start us off here.
Okay.
So first of all, thank you for...
Oh, it's logged in.
Okay, let me just plug that in.
Yeah.
So thank you for the invitation. I'm delighted to be here. I come all the way from Florida. Yes, we do have winter in Orlando. It's usually the 26th and 27th of January, just in case any of you wondered that. So before we get started, I have just a couple of questions to ask. First of all, are there any folks in the audience who actually know what amateur radio is, have personal experience with knowing what it is? Okay, maybe half a dozen of you. Is there anybody here who's actually a licensed amateur radio operator? 1, 2, 3, 4. Which is really quite amazing. I gave a similar presentation at an IEEE sponsored conference in Naples, Florida earlier this year, and I would say there were 100 people in the audience and not a single one of them was a licensed amateur radio operator, which was a little bit frightening because it was full of, and I say this respectfully, techno geeks. There were people who were electrical engineers and communications and physics and things like that, and which is my background as well, but I was relatively surprised at that. So as we're ready to get going here, I do have a comment about laws. We talked about some of the laws that the FCC is working on. Shall I do something here? Let's see, unknown device detected. We'll just do this. I can't ignore it. Close it.
This is what we do with security alerts.
This is good. I'll close it again. I'll close it again. Okay.
Maybe just go down to your PowerPoint on the bottom.
Yeah, it wouldn't let me do that. Let's try it again. All right. Okay. So about laws. So most of you know what Ohm's law is. Show of hands, Ohm's law. Okay, that's good. Murphy's law? Murphy's law? What about Cole's law? Thinly sliced cabbage. Okay, all right. Moving on. So let me talk a little bit about why the next 19 minutes or whatever my half hour turns out to be. Okay, I'll try now because I am the one standing between the rest of you and cocktails, and I understand that. But let me talk to you about why this is going to be different. So I'm a technologist. I'm an obsessive technologist. I'm curious about everything technology related. I wanted to be an air pollution scientist when I was a kid. I ended up studying electrical engineering, then civil engineering, then chemical engineering. So I'm a techno geek of my own. But this presentation is really not technical. So I want you to take this in the context of pretty much everything else you've seen today is rooted in technology and how important technology is to solving problems. This actually takes a little bit of a different track. It talks about things that are non-technology related and how those things may be just as important in solving a problem as those technology issues. So a little bit about myself. I became a shortwave listener, if anybody knows what that is, listening to Radio Moscow, The Voice of America, Radio Prague, Radio Australia, and so on. When I was 12 years old, I got my first ham radio license when I was 14 years old. I do have an electrical engineering degree, which is why I suppose that validates the fact that I was invited to the conference here, because I've got to have those EE letters in my credentials. Yes, I've lived in upstate New York before. Schenectady, New York. I was actually born in Schenectady, the city with the zip code 12345. In case that turns up on a trivia test, Schenectady has the zip code 12345. Although I was born before zip codes, so I was not born in that zip code. And I'm kind of and I don't mean this in a boasting manner, but it's a factual thing. I've started a few companies in the field of wireless communications. I started a company in 1992 that was the first company to actually take distributed processing and apply it to mobile data for police. Motorola, somebody, you've heard of Motorola before? It's a small company headquartered maybe here in Chicago, Schaumburg. Motorola had done something called mobile data terminals, and we took it to the next level by applying distributed processing, putting laptops in police cars, and we went from 3 guys in 3 garages to $150 million exit in 1999. So I know a little bit about technology and how to apply it, but again, forget all that because this isn't going to talk about technology. This is going to talk about my personal perspective and what amateur radio has done to my brain with regard to solving some of these real-life problems. So just a couple of really strange things. If you thought I was weird to start with, this is going to confirm it for you. So in 1979, I did something really strange. A little bit of background. Ham radio operators are very competitive. There are contests throughout the year. There are all kinds of things, and you need to win them. And winning them means that you get $1 million. No, you don't get anything. You get a certificate to hang on your wall, and you get bragging rights. However, there are people who collect countries. If you talk to a specific country, you get to check it off on your list. And he who has more countries has got better bragging rights. Well, there's this little place in the South China Sea called the Spratly Islands. It's been in the news a lot in the last decade or so because the Chinese are adding sand to it to make it bigger and claiming oil rights and things like that. But in 1979, it was a hotly contested area. China was at war with Vietnam at the time. It was after the US had left the Vietnam War. And it was a pretty hostile area. Although our contacts at an agency, sometimes called the Department of Agriculture in Virginia, although many of us know that it's not really dealing with agriculture, told us it was safe. No problem going there. Well, we found Vietnamese troops when we were there and they shot at us. They didn't kill us, but they did kill 3 Germans the next year who tried to go back there and do the same thing. And we went for the sole purpose of bringing radios and bringing towers and bringing generators and setting up an ad hoc operation so we could give out Spratly Island to all of those deserving ham radio operators around the world. In 72 hours, we made 13,000 radio contacts with people around the world. Kind of interesting. Another weird thing that I did is I had occasion for work to go to China on a regular basis. And I started doing it in the late 1970s, early 1980s. And there had been a dearth of amateur radio activity in China since the Cultural Revolution had taken place in the mid to late 1940s. There had been no amateur radio operation at all until, mysteriously, in 1982, BY1PK, BY is the prefix for China, 1 is the prefix for Beijing, and PK stood for Peking University. So the university club station started making contacts. Well, it was interesting. They'd get on the air and they'd say, hello, this is BY1PK in China. And of course, everybody needed China to check it off on their list. And there would be this massive, what we call a pileup. And they'd make 1 or 2 contacts and then they couldn't hear anybody because it was just cacophonous. And they'd go away. And this was very frustrating. So I offered to train them in how to handle these kind of pile-up situations. And I heard nothing for months. And then all of a sudden, out of the clear blue sky, I received a telex. Anybody know what a telex is? Okay. From the China Radio Sport Association saying, come on, why don't you come and help us train the operators? So I became the first non-Chinese to operate amateur radio since the 1940s, when I did it in 1983. It's kind of strange. And then here's one little thing that's more relevant to the topic today. So in 1972, there was a major flood in, I'll call it south central New York, eastern Pennsylvania. Some of you may have actually lived in that area and know all about this. The Chemung River overflowed, flooded nearly the entire city of Elmira, New York, and also went down into the cities of eastern Pennsylvania as well. The worst flood in New York since the 1940s. Tens of thousands of people were evacuated from their homes. And I was in Buffalo, on my way back from Buffalo, driving my 1972 Chevrolet Vega with my HF radio installed under the dashboard, and they put out an emergency call for amateur radio operators to help with relief efforts. And I said, gee, I wonder what that's all about. So I drove to I drove to Chemung County, to Elmira, and I became part of the disaster relief team. And we actually were the only people who were coordinating arrival, delivery, distribution of sleeping materials, food, medicine, blankets, and so on that were arriving at a nearby airport, courtesy of the government in their C-130s. It was really eye-opening. I was there for 5 days, and I learned all about what disaster relief is and should be. It's fascinating, absolutely fascinating. I don't think it would be the same today. Number one, I'm not as impressionable as I was when I was 17 years old, but also technology has moved on a little bit, and let me talk about that just a bit. So one of the laws we need to pass, by the way, if the gentleman from the FCC is here, you might want to take this under consideration. We need to stop disasters. Okay, so we can put that in the law, and if it takes as long as most laws to do, then sometime between now and 2030, there'll be no more disasters. But there are all kinds of things that we don't anticipate that plague us on a regular basis. When I say don't anticipate, yeah, we can forecast hurricanes like we forecast Hurricane Dorian. And I know you folks don't live in Florida, maybe 1 or 2 of you do, but I do. They forecast Hurricane Dorian to make a mainland hit right between Miami and Daytona Beach. And instead of doing that, it decided to park itself over the northwestern Bahamas for 3 days and not move. And we actually never saw any effect of a hurricane whatsoever. So you can have the downside of it and you can have the upside of it. So a hurricane can come without warning. It can change wherever it wants to go. There are floods, tornadoes, other kinds of emergencies that are not weather related. We talked a little bit about forest fires earlier and what they're doing in California, volcanic eruptions, and there are probably all kinds of disasters that I haven't even considered here. But I'm going to talk a little bit about hurricanes. Hurricanes are very highly visible. They're very publicly aware. They're covered on the news. Everybody knows what they're all about. So in order to feed my presentation here, I relied on some information from a very good friend of mine that I've known since he and I were both in high school. He was in high school in Indiana, and I was in high school in Massachusetts. He's now the emergency coordinator for the Virgin Islands. He's an amateur radio operator, as I am, and his job has to do with two-way communications. He works for a tower company. But his side job, when he's not doing that, is being the emergency coordinator, in particular for St. Croix. And he works with emergency coordinators from others in the Virgin Islands as well. So he knows all about what's going on, and he is part of the people I'm going to talk about in this presentation. So Hurricane Irma, 2017. Unfortunately, the Virgin Islands got whacked twice within rapid succession. Devastated Barbuda, St. Thomas, and St. John. Barometric pressure was 914 millibars, which compared to Dorian was actually not so bad. But 160 mile an hour sustained winds, 200 mile an hour surface gusts. I mean, this is pretty much devastating to anything in its path. Fifth costliest in history. So that's what it kind of looked like. And these are pictures that were supplied to me by my friend K9VV in the Virgin Islands. Well, guess what? A few days later, Hurricane Maria. Even a lower pressure, 908 millibars, 165 mile an hour sustained winds, maximum surface gusts above 200 miles an hour. And again, this was about the same range as Dorian, which had gusts of about 210 or 215 miles per hour, if you believe what the reports say. This was the 10th strongest Atlantic hurricane ever. Devastated St. Croix, 95% of utility poles were destroyed. Keep that in mind for just a second as we go through the presentation here. And this received the most media attention of almost any hurricane, actually any hurricane in the Caribbean, not more than Katrina, but any hurricane that affected the Caribbean. And here are some pictures of what Maria did. They kind of look like the same pictures. I didn't use the same pictures. These, in fact, are traceable back to Maria. So let me talk a little bit about communications. So when one thinks natural disaster, one thinks of all the things we've been talking about during the day today, and we'll be talking about a little bit tomorrow, which are these communications infrastructures that are designed to be infallible, maybe, at least resilient, flexible, usable, and able to provide the service that they were intended to deliver during the time of a natural disaster. And this is an eye chart, kind of. It's got all these things. If I had a laser pointer, I'd point you to all the little linkages and things here. It's pretty complicated. This is a very, very basic cellular system. I say fixed wireless. It could be mobile wireless as well, but it's cellular. Very, very simple, right? No, not really. So there are a lot of things that depend on commercial infrastructure. There's backhaul, there's power. You need to have poles if you're going to have cellular antennas, or you need to have towers. And if 95% of the towers and poles get knocked down, guess what? You don't have them anymore. So just a little bit of fragility. This is maybe not a typical tower, but I mean, I've seen lots of towers like this in my career in the wireless industry. The benefits of 4G and 5G wireless, of course, is that they're already in place. Somebody else maintains them. It's the telecom providers that maintain them. That's great. We as citizens don't have to do anything. But some of the weaknesses, the complex infrastructure is vulnerable. And the more complex it is, the more components are involved, the more vulnerable it becomes. It relies on things like towers and backhaul. And if they go away, the service goes away completely. And it's capacity limited, in particular at the time when it's needed, when there is an emergency. Now, with respect to the particular provider that was indicted by this headline, I eliminated the word Verizon. I eliminated the provider. It said Verizon Fiber suffered unprecedented damage from Hurricane Michael. This had happened after those hurricanes, but before I made this presentation. And one of the gentlemen who presented earlier today talked about the fact that one of the issues with providing service after a disaster and restoring power and restoring cellular service was the backhaul itself. And this is an example where in Florida in particular, the backhaul just never came back. So if you don't have backhaul, you don't have a service. Now, this is the amateur radio network. This is HF radio. Does this look a little simpler than the diagram that I had up there before? It's got two things that we provide. It's got a transmitter and it's got a receiver. And it's got this thing called the ionosphere. The ionosphere, for those of you who haven't studied physics, the ionosphere is just an ionized layer. It's an ionized arc. It's just like a mirror. You send a radio wave up to it. It's a little more complicated, but in a simple form, you send a radio wave up to it at a certain time of day at a certain frequency, and the radio wave bounces off and comes back to Earth. And that allows us to communicate way beyond the curvature of the Earth. In fact, people ask me often, how far have you talked by amateur radio? And I say, well, I've talked to somebody in California the long way over Europe. So you can do that. And actually, you can bounce signals off the moon, and that's even longer. But with regard to this model of using the ionosphere as a reflective mirror, it's pretty simple. So what makes it even simpler is I can go get a transmitter out of the trunk of my car, and I can go plug it in, or I can go get a Honda generator, and I can put a little bit of fuel into it. I can start up the generator, plug my transmitter in, throw a wire over a nearby tree, and I could talk to somebody in Europe 15 minutes from now. Pretty impressive, pretty impressive. I don't rely on infrastructure. I don't rely on backhaul. I don't rely on towers. I don't rely on anything that the commercial infrastructure has to provide me. Now, this is the VHF-UHF network, which is a repeater. Many of you may have heard that context before. This is the complete repeater topology for the Virgin Islands. And you can see we've got St. Thomas, St. John, and St. Croix, STT, STJ, and STX. But repeaters are pretty simple as well. I had a repeater at my house when I lived in Massachusetts. I just put an antenna 50 or 60 feet up my tower. I bought a little piece of thing, and I piped it all together, and I turned it on. And anybody who wanted to could actually talk. As long as they had range of my little 50-foot tower, they could talk to each other. Again, I could make it go on emergency power. Nobody needed to have any infrastructure, no commercial backhaul necessary, nothing required from the outside world. So again, self-contained and manageable is a key. So the thing about disaster response, again, we talked about technology. Technology is important, but when technology fails, what do you do? If technology isn't available, what do you do? Well, you've got to have training. So even the best alternative infrastructure, like the one I talked about, isn't going to be very helpful if you don't have people who are trained to be able to operate it and have it perform the function that it's intended. So amateur radio operators can participate in one of a number of different organizations, and I'll fast forward through this a little bit in the interest of time. But there are multiple functions that are provided. There's a little bit of project management, there's a little bit of frontline communications. They actually design, build, implement, maintain emergency operations centers in every state and every territory of the United States. They program radios, they understand where interoperability is important, they know where the weather channels are so they can listen to the weather channel if it happens to be on the air. They coordinate with, and in some cases are embedded in, the emergency forces of people like TSA or police or fire or other emergency responders. In fact, in the case of Hurricane Irma, HAMS assisted with air traffic control because the entire air traffic control system was down. So how did planes land? The amateur radio operators coordinated it for them. So these are two options. Those of you who are licensed radio operators might know about RACES, which is coordinated by the federal government, and another one called ARES, which is Amateur Radio Emergency Service. Both of them are staffed with volunteers. These folks are not just plain old volunteers like, hey, I think I got some time on Saturday to help out. They're actually trained. They actually go through certification in disaster relief and disaster relief communications. So again, their primary purpose is not to be the primary communicators, but it's to be the backup communicators when that primary system fails or becomes infallible. So pre-disaster checklist. Has anybody here been through a disaster where you've lost power, you've been flooded or something like that? You know, I have. A few? Okay. So you know, it's really easy to come up with this list afterwards. It's kind of hard to come up with this list beforehand because you got lots of other things on your mind. But it's worth taking away. You can download these slides from the website if you want to do this. Who's evacuating, who's staying, who is available as a resource, what other agencies can be called upon for certain specialized services or functions. What is the operating schedule for people? Who's going to be available on this shift, and then who's going to take over in that shift? And then, of course, it's a bit trite, but expect the unexpected, because the unexpected always happens. Murphy's Law again. So you need to have contingency plans to put into place when those deviations occur. So just a little bit about, I did some pros and cons about the fixed wireless or the cellular paradigm that we talked about, which is the one that we all rely on for communications during a disaster. Let's look at amateur radio. Key benefits: can be deployed virtually anywhere. And as I said, I can deploy this in my backyard. And I'll show you a slide. In fact, there are some slides of some folks putting up towers right here. Very simple to operationalize. It doesn't require anything more than somebody who has a license and somebody knows how to plug in a piece of coax into the back of a radio panel and turn the on switch. It's not dependent on any existing infrastructure at all. You might say it's dependent upon power, availability of power, but as I said, I can go down to Home Depot and I can purchase myself my own little portable power pack, and off I'm running. You can do batteries, you can do generators, and they last quite a long time because, again, it's a very simple model, so we don't have lots and lots and lots of things to light up. It's a relatively simple model. And there are a large number of trained volunteers, so there are people who can step in and actually make this all work. Potential weaknesses, it's not accessible to the general public.
Why do you say that?
General public can't get involved in the communications themselves. So if you're on a cellular system, you're the general public, you can take your cell phone and you can make a call. You can make a 911 call, or you can coordinate with somebody. But you can't do that unless you have a license. Right. Which is great, straight man, because that's coming up in 2 slides. So that's good. That's right, exactly. Another potential weakness is it can be affected by ionospheric disturbances. So there are things that happen to the ionosphere that are related to the sunspots and solar flares, and it's all astrophysics. And I understand it pretty well, but it's really complicated. I understand it to the point to know that I really can't explain it in the time frame I've got here. But suffice to say that ionospheric disturbances can kill everything. Like all of a sudden, boom, done. You're talking to somebody, and then all of a sudden, 15 minutes later, there is absolutely no propagation to that part of the world anymore. And this applies only to those communications that are not line of sight. If it's line of sight communications, that's a different story, talking about bouncing things off the ionosphere. So lessons learned, okay. I've been involved in disaster relief off and on my whole life, and I could tell you that you need to confirm something that doesn't make sense. And that's kind of a good life lesson too, isn't it? Somebody tells you something, you say, I'm not sure that really makes sense. Be curious. Dig into it. For example, a real experience that was related to me by my friend in the Virgin Islands, somebody was talking about Delta Kilo Alpha. And they actually didn't say Delta. They say, it's got DKA. And they heard EKA. And they said, what's EKA? And they said, I don't know what EKA. That person's got EKA. And they relayed this to the first responders. Delta Kilo Alpha would have clarified that. It's DKA, which is diabetic ketoacidosis, which is a life-threatening condition for somebody who's afflicted with it. So that had to be confirmed 3 times before it was done. So again, lessons learned. If you don't understand something, clarify it. Pay special attention to detail, maintain vigilance, and so on and so on and so on and so on. And by the way, the last point on here is pretty important. The FCC recognizes the public service value of amateur radio through the free license grants that we enjoy. I don't pay for a license anymore. I last paid for a license probably in 1985. And the FCC decided it's not worth putting people through this. This is a valuable service. So let's not charge people. Let's not penalize them for it. And incidentally, by the way, during Hurricane Dorian just a month or 2 ago, actually just a month ago, there was a waiver granted for use of specific digital modes that are normally not allowed in certain amateur radio bands, something called PACTOR. And the FCC extended the waiver for the entire duration of the hurricane recovery operations. So again, the FCC is very much in tune with recognizing the service that amateur radio provides.
Bill, what about the technical side of the requirements for licensing?
I do. I have a slide about that. So aftermath, we don't need to see this, blah, 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 blah. Okay. So just 2 things here. So practice makes perfect, and I think that's true in a lot of things in life, if not everything in life. There are contests almost every weekend. And you say, what's a contest? Well, we go to some station, maybe our own, if we have one at home, or maybe a collaborative station, or maybe a radio club at a university, and we talk to people around the world. And you get a score. How many people did I talk to? How many countries did I talk to during the time period? I multiply some things together. I add them up for each band that I've communicated on, and I get a score. And I get bragging rights because I won for Central Florida, or I won for Nantucket County, Massachusetts, or whatever it might be. But there are these contests that are really, they're opportunities to improve your skill. Essentially, they're practice. They're practice for the delivery and crisp handling of information over a 2-way radio link. I prefer the ones in Morse code. I'm fluent in Morse code. Can you say that? I can do Morse code sending and receiving at 60 words a minute. I've been able to do that since I was 14. So I love that. The thing about that is that you don't have to spell things out because they're already spelled out. I mean, you're spelling when you send it. If I send Bill, it's dotted it, and I don't have to figure out what I just sent and say, was that a B or an L? Because it's already spelled out for you. There are also these things called simulated emergencies that these organizations I talked about conduct on a regular basis. And then there's the big mama of all rehearsals, which is something called Field Day. And Field Day is an activity that happens every June all over the United States and Canada. And people literally start off with a mountaintop, an open field. In Orlando, we do it just east of the executive airport near the 911 center, coincidentally, but it just happens to be a big open field that's owned by the city. And we drag our towers and coax cables and radios and tents and what have you, and coolers of, not beer, but coolers of soft drinks and things like that. And we set them up in as quickly as we can, and we start transmitting to other people who are doing the same thing that we're doing. Last year, 2018, 1,253 people entered this particular competition in the so-called temporary station category, which means they started with an open field and they put up towers just like the one you see in the picture here. 35,000 people participated in this competition, and it happens every June. And it's a rehearsal. It's called Field Day. So what are the takeaways? First, the key to successful emergency service response is preparation. Duh, we know that. The key to many things in life is preparation. But to be effective, disaster relief communication must be well coordinated and well executed by competent, well-trained personnel. And remember, we're not dealing with people who are working for the government, who are working for private sector. We're dealing with people who are volunteers. So the onus is on these volunteers to get themselves trained by participating in one of these organizations. And as we talked about at the beginning, whether it's cellular, fixed wireless, wired internet, point-to-point, no network is infallible. Something is eventually going to fail. Something is eventually going to break, in particular when you need it the most, and that's during a natural disaster. So there have got to be backup plans in place as to how are you going to deal with that emergency if your primary service is not available. Infrastructure, equipment, processes and procedures, and those are all taken care of, available manpower, specialized training, and so on and so on and so on. So just a couple of final thoughts. You probably are surprised at this because you think that ham radio operators are that old guy in the basement next door who winds enameled wire around toilet paper rolls and then builds something that makes sparks. No, that's 1940s thinking. There are 822,000 licensed amateur radio operators in the United States. So I'm actually very happy to see that we have some in the group today because, as I said, I was really disappointed when I talked to a group of geeks in Florida, and nobody was a ham, not a single one. By the way, my wife is a licensed amateur radio operator, and so is my daughter. So it's also contagious, so be careful. Entry-level licensing is easy. It takes about a week. I mean, you people in the room here, the technical part of it, I'm sure, is a slam dunk. There's a bunch of regulations you'll need to learn. What can you do? What can't you do? Under what circumstances can you do that? And nomenclature and naming and what are certain modes called and so on and so on. $50 worth of study books. That's all you need. You can even go online and you can find study guides that are available for free. And local clubs hold classes and administer the exam. Last weekend I was in Melbourne, Florida at the Melbourne Ham Fest. That's a fairly common term for a group of ham radio operators getting together to swap things at a swap meet and listen to presentations about who's doing what to whom and newest technology and operating techniques and things like that. And they offered classes. They also offered exams. So a number of people were sitting in the room, young people, fortunately, taking the exams, and they'll be off and running with their licenses fairly soon. So that's all I have for you today, and I'm sorry that I went 11 minutes over, but I actually got handed the baton with 12 minutes, so I'm actually 1 minute early. So, thank you. And if there are any questions, you can either handle them now, or I'll be standing over there drinking a Diet Coke with the rest.
Any questions? Well, Bill, thank you very much. Oh, yeah.
I'm going to appreciate the contributions that amateur radio makes, but comparing it to fixed wireless seems like less than an engineer should do, given that much of emergency communication, given capacity, is done by satellite radio storage, which is equally portable, in many cases more so than a VHF or even shortwave antenna. So I don't think that comparison was quite fair. I don't think it does justice to the contribution that it can make, because we all know that there are two aspects to that. Distance, in some cases you can, in some cases you don't, and capacity. Let's just say shortwave capacity measured as the whole races and Paris network is measured in maybe a few thousand bits a second. In that, and communication demand in major disasters probably measured in gigabits a second.
Yep. But I exaggerate a bit to make my point, so thank you for pointing that out. But I can say that in the absence of that primary communication infrastructure, this is a really good second alternative. Now, you can say satellite. Satellite's awesome. Amateur radio operators use satellite communications as well. But in the case of satellite being rolled in for a natural disaster, it's a great idea. The problem is if you need to communicate with people in the area, satellite really doesn't help you because they have no infrastructure in the area. So let's talk about the Bahamas. Okay, so let's talk about the Bahamas where the hurricane came and parked itself over, I guess, which island was it? Abaco Island for 3 days. So there was no infrastructure to speak of except some wired internet was available. And there needed to be some way to get information off of that island and back to elsewhere. Now, there was some limited media feed. People were sending information through wired internet. But that didn't interact, that didn't actually help anybody who was in need of emergency services. It provided information to the rest of the world that was in it. So one other aspect of that, by the way, I wanted to mention was another aspect of how amateur radio helps in these kinds of situations is it's a very important but often overlooked area. In fact, I overlooked it myself, and that is something called health and welfare. So after the fact, people can go to a central location that's well publicized. In the case of the Virgin Islands, it was the communications center. People could go there and check in and say, I'm okay, and their name would be added to a list, and that list would be constantly updated by HF Radio to somebody back in the United States who was adding it to a bulletin board that could be accessed online. So people could see, hey, my cousin Hermann is fine, or whatever. So I appreciate your comment, and I agree with it. I exaggerate to make my point. There are certainly many alternatives to fixed wireless in the case when fixed wireless breaks. This is just one of them that I'm very familiar with.
Well, great point.
Questions? Excellent.
Thank you, Bill. I met Bill last night for the first time, sat down for a 5-minute conversation, and we ended up saying goodbye about 3 hours later. So welcome back certainly next year, and thanks for bringing a different spin. All right, let's go partake in festivities.